For more than a century, the piranha has been one of the most feared animals on the planet. Films turned it into a swarming river monster. Headlines described a fish capable of reducing large animals to bone in minutes. The name alone became shorthand for something relentless, unstoppable, and completely without mercy, and almost all of it traces back to a single moment, one demonstration on one river more than 100 years ago that may have been staged from the beginning. The myth spread anyway, and it spread so completely that when scientists began studying the real animal, the one actually living in these rivers, what they found was so different from the legend. A red-bellied piranha can generate one of the strongest bite force to body size ratios ever measured in a vertebrate. Yet attacks on healthy humans are extraordinarily rare. Some members of the piranha family are almost entirely vegetarian. Researchers have recorded piranhas producing distinct sounds to communicate with one another and avoid physical conflict, which raises a question that goes beyond piranhas entirely. How does a creature become one of the most feared animals on Earth when the fear is built almost entirely on a story someone else invented? Because the real piranha is stranger than the myth. Not safer, not less interesting, stranger. The animal that actually lives in the Amazon is more complex, more surprising, and in some ways more unsettling than the creature Hollywood decided it was. Tonight, we follow the real story behind one of the most misunderstood fish on Earth. But before we do, let me know in the comments. Are you listening to this to fall asleep? Or you're here only for the knowledge? Now, let's descend into the rivers where the legend of the piranha began. Long before the first stories about flesh stripped from bone began drifting through newspapers and cinema screens, the rivers themselves had already been moving across northern South America for millions of years, spreading through forest and sediment in slow continental rhythms. The Amazon basin covers roughly 7 million square kilometers, the largest tropical rainforest on Earth, a living system so vast that clouds form above it from its own evaporation. Nearly 10% of all known species on the planet exist somewhere within this network of flooded forest, hidden tributaries, oxbow lakes, drowned root systems, and dark channels that disappear beneath overhanging vegetation. Every hour, somewhere beneath the canopy, another fish species brushes through submerged branches that science has still not formally described. The river at the center of this system carries a volume of fresh water unlike anything else on Earth. Roughly 1/5 of all fresh water entering the world's oceans arrives through the Amazon alone, more than the next 7 largest rivers combined. From space, the sediment plume stretches into the Atlantic like diluted earth, visible hundreds of kilometers from shore. Yet the piranha exists entirely inside this freshwater world. Salt water is a boundary it cannot cross. The ocean is not a corridor, but a wall. A piranha cannot drift outward and colonize distant continents through marine routes the way some fish species can. Its entire evolutionary history remains locked within the rivers of South America. Across those rivers, however, the world changes constantly. Piranhas inhabit 4 major basin systems: the Amazon, the Orinoco, the Paraguay, and the San Francisco. Each possesses its own chemistry, seasonal rhythm, sediment load, and ecological pressures. Water itself becomes part of the animal's biology. In some regions, the rivers run black beneath the forest canopy, stained dark by tannins released from decomposing vegetation. These black water systems are acidic and nutrient-poor, carrying the color of steeped tea through submerged forest, where visibility collapses within arm's reach. In other places, the rivers arrive pale and opaque from the Andes, heavy with suspended sediment eroded from mountains thousands of kilometers away. These whitewater systems are richer in nutrients, more biologically productive, and constantly shifting with silt. Different piranha species adapted themselves to these conditions over immense spans of time. Coloration shifts subtly between populations. Behavior changes with visibility and food density. Diets expand or narrow depending on flood cycles and competition. The familiar image of a single universal piranha begins dissolving almost immediately once the rivers themselves are understood. There is no singular environment producing a singular animal. There are dozens of ecological worlds shaping dozens of related fish. Even the word piranha hides a much larger family behind it. The broader group, Cerassalmidae, includes pacus and silver dollars alongside the more familiar carnivorous species. Some members possess the triangular cutting teeth that entered popular mythology. Others evolved broad crushing molars suited for seeds and fruit, depending on which taxonomic system an ichthyologist follows. Somewhere between 30 and 60 recognized piranha species currently exist, and the number continues shifting as researchers formally describe new populations from isolated tributaries and flooded forests. In parts of the basin where scientific surveys remain limited, entire branches of the family may still move through the water undocumented. This is the ecological reality that produced the animal long before the mythology arrived. A fish shaped not by horror stories, but by chemistry, flood cycles, predators, drought, forest fruit, sediment, darkness, and the immense hydraulic pulse of South America itself. And once that world comes into focus, the myth surrounding the piranha begins to feel strangely artificial, as though it had been lowered onto the river from somewhere very far away. In the early months of 1913, Theodore Roosevelt was already drifting away from the White House and deeper into the role he seemed almost biologically designed to inhabit: explorer, hunter, public intellectual, collector of danger. The former president entered Brazil alongside the Roosevelt Rondon Scientific Expedition, a venture led in part by the Brazilian military officer and explorer Cândido Rondon, whose work mapping remote river systems had already become legendary within South America. Much of the territory ahead remained poorly documented by Western science. Rivers curved through forest without reliable maps. Entire tributaries disappeared into regions still described in expedition language as unknown. Roosevelt arrived with immense international visibility and a well-established appetite for spectacle. His Brazilian hosts understood this clearly. Along one stretch of river, preparations began quietly before his arrival. A section of water was enclosed with nets and isolated from the surrounding current for several days. Inside the trapped pool remained a concentrated school of piranhas cut off from normal feeding routes. The fish were intentionally deprived of food while local organizers prepared the demonstration that Roosevelt would later describe to the world as ordinary river behavior. When the moment finally came, a weakened cow was driven into the enclosed water. Blood entered the current almost immediately. The trapped fish surged forward in violent competition, stripping flesh rapidly from the animal in the confined space. Roosevelt watched the scene from the riverbank and recorded it in language thick with astonishment and theatrical intensity. In his account, the piranhas became creatures of extraordinary aggression, fish capable of reducing large animals to skeletons within minutes. The passage carried the breathless cadence of adventure literature, and for readers far removed from Amazonian rivers, there was little reason to doubt it. The following year, Roosevelt published Through the Brazilian Wilderness. The book circulated widely across Europe and North America, reviewed not simply as memoir, but as authoritative natural history from one of the most recognizable men on Earth. The Piranha passage detached itself almost immediately from the larger text. Excerpts appeared in magazines and newspapers. Encyclopedias repeated the description. Nature guides cited Roosevelt directly. School textbooks folded the story into educational material for generations of readers who would never see a South American river in person. A staged feeding event became accepted biological fact through sheer repetition. What disappeared almost entirely from the retellings was the structure surrounding the encounter itself. The netted enclosure vanished from public memory. So did the deliberate starvation. The confined conditions, the injured cow, the orchestration of the spectacle, all of it faded until only the violence remained. Removed from context, the demonstration transformed into evidence of an animal's permanent nature rather than evidence of what starving fish do inside an artificial trap. Across Brazil and Venezuela, many local communities reacted to the growing Western mythology with quiet bewilderment. People who had spent their lives swimming, fishing, and washing clothes in rivers inhabited by piranhas struggled to recognize the creature being described abroad. The fish they knew demanded caution during low water or feeding conditions, but not terror. Children entered the rivers daily. Fishermen handled piranhas constantly. The monstrous version spreading through foreign publications seemed detached from ordinary experience, like a story invented about an entirely different animal. Decades later, the mythology expanded again through cinema. The 1978 film Piranha transformed the fish into a modern horror icon for international audiences raised on creature features and disaster narratives. Schools of ravenous fish erupted across screens in choreographed frenzy, industrializing the image Roosevelt had first helped establish more than 60 years earlier. Yet beneath the exaggerated violence and theatrical blood remained the same intellectual foundation laid beside that Brazilian riverbank in 1913. One carefully arranged demonstration, amplified by fame, publishing, and repetition, altered the global identity of an entire family of animals. The myth settled over the piranha so completely that for decades the real fish beneath it became almost invisible. A red-bellied piranha suspended in still water does not immediately resemble the animal built by posters and tabloid illustrations. The body is compact, almost delicate at first glance, no larger in most adults than a human hand spread across a dinner plate. Light moves softly across silver flanks that shift toward olive beneath darker water, while the underside glows with the deep red-orange coloration that gave the species its common name. This fish, formerly known as Pygocentris natereri, became the biological reference point for most modern piranha research, not because it is the largest or rarest member of the family, but because it is widespread, adaptable, and unusually well suited to life inside the flood systems of tropical South America. Its shape reveals the environment long before the jaw does. The body is laterally compressed, flattened from side to side like a blade turned vertically through the current. This architecture sacrifices endurance for maneuverability. A red-bellied piranha is not built for long migrations through open water. It is built for sudden directional shifts between submerged roots, flooded branches, and crowded schools of fish moving through narrow channels. Short bursts of acceleration matter more here than sustained speed. In blackwater tributaries, where visibility collapses almost immediately, hesitation can become fatal. The head carries most of the animal's visual weight. The lower jaw protrudes slightly beyond the upper, producing the compressed facial profile that later became exaggerated in cinema and illustration. Yet beneath the mythology sits a remarkably precise feeding instrument. The teeth are triangular and tightly interlocked, forming continuous cutting surfaces when the jaws close together. Unlike the puncturing bite of a crocodilian or the tearing motion of many mammals, the piranha bite operates more like a set of biological shears. The force arrives in a rapid lateral slicing motion designed to remove tissue cleanly and efficiently in a single closure. Each tooth fits into the next with mechanical precision, leaving almost no gap between cutting edges. The structure resembles engineering more than ornament. Even more unusual is the replacement system hidden beneath the gums. Most fish replace teeth individually and continuously throughout life. Piranhas do something almost entirely unique. Entire rows are shed and regrown simultaneously in alternating quadrants of the jaw, one side remaining functional while the other regenerates. The cycle continues across the animal's lifespan, maintaining cutting efficiency without leaving the fish fully vulnerable at any point during replacement. Running quietly along the length of the body is another system, less visible but no less important. The lateral line forms a sensory network capable of detecting minute pressure changes and vibrations traveling through water. To a piranha, movement itself becomes geography. A struggling fish several dozen meters away produces a distinct hydrodynamic signature that propagates through the current long before it enters visual range. In turbid rivers where suspended sediment and tannins reduce sight to shadows, the lateral line becomes a continuous stream of environmental information, translating turbulence into awareness. The eyes complement this world rather than dominate it. They are proportionally large, positioned to provide broad fields of view in dim conditions beneath flooded canopy and stained river water. Retinal sensitivity favors low light rather than sharp detail, allowing the fish to navigate environments where sunlight rarely penetrates clearly. Juveniles carry spotted camouflage patterns across their bodies, helping them dissolve into submerged vegetation and broken light. As adulthood arrives, the markings fade into smoother metallic tones, better suited to schooling behavior and deeper channels. Even lifespan complicates expectation. Under favorable conditions, a red-bellied piranha may survive for nearly 10 years in the wild, far longer than many people assume for a fish of its size. Over that decade, it becomes not a chaotic force of instinct, but a highly specialized freshwater animal, shaped carefully by current, darkness, competition, and sensory precision. The anatomy that once fed mythology begins, under closer observation, to resemble something quieter and far more exact. Inside the head of a red-bellied piranha, a remarkable amount of space is devoted to a single task. Beneath the smooth curve of the skull sits a dense arrangement of jaw muscles packed tightly against bone, filling much of the head with contractile tissue. In anatomical cross-sections, the adductor muscles bulge outward with unusual proportion for an animal of this size, giving the face its rounded profile and compressed appearance. Much of the fish exists in service to the bite. The structure itself is among the most mechanically efficient cutting systems documented in any vertebrate. Not merely sharp, not merely forceful, but refined through millions of years into a highly specialized tool for rapid tissue removal in crowded freshwater ecosystems where hesitation can mean losing food to competitors. The jaw closes with extraordinary speed and precision. There is no prolonged struggle once contact is made. The motion is immediate, high force, and brief, a single closure followed by release. The fish removes material cleanly and withdraws before turbulence and resistance disrupt the strike. In 2012, researchers publishing in scientific reports attempted to quantify this force directly. Using sensor-equipped measuring devices placed inside controlled tanks with red-bellied piranhas, they recorded the bite pressures generated by adult individuals during feeding strikes. Large specimens produced forces of approximately 320 newtons, nearly 30 times their own body weight. Relative to body size, this exceeded the proportional bite force of a great white shark. Gram for gram, the piranha bit harder. Yet the significance of the bite lies not only in raw force. The geometry of the teeth transforms pressure into efficiency. Each triangular cusp aligns precisely against its opposing partner, creating continuous serrated edges that behave more like sharpened industrial blades than ordinary fish dentition. The closure concentrates energy into narrow contact points, allowing tissue to shear apart rapidly rather than crush under pressure. A clamp and hold predator relies on grip. The piranha relies on instantaneous transfer of force through cutting surfaces honed by evolutionary repetition. Even the enamel carries traces of this refinement. Studies examining the microscopic structure of piranha teeth found fluoride-rich mineralization closely resembling the enamel chemistry of mammalian teeth. The similarity emerged independently through convergent evolution, a process in which unrelated lineages arrive at comparable biological solutions while adapting to similar mechanical demands. Mammals and piranhas diverged across immense evolutionary distances, yet both arrived at nearly identical strategies for producing hard, durable cutting surfaces capable of resisting wear. The deeper one looks into the jaw, the more ancient the design appears. Fossilized piranha teeth recovered from Miocene deposits in northern South America, dating back roughly 25 million years, already display the same triangular architecture seen in living species today. The proportions vary slightly across extinct and modern forms, but the essential design remains intact across geological time. Few biological structures remain so stable for so long without fundamental redesign. Evolution rarely preserves inefficiency. The persistence of the piranha tooth suggests a system already operating near optimal performance within its ecological role. That role, however, emerged from environments profoundly different from the mythology later attached to it. These jaws evolved among dense schools of armored fish, protected by heavy scales and defensive spines. They evolved beside large reptiles, moving through flooded channels and within ecosystems crowded by competition for limited resources during seasonal drought. The bite belongs to a world of submerged roots, shifting floodplains, and opportunistic feeding, not to cinematic visions of relentless predation directed toward humans. Seen in isolation, the piranha jaw appears almost improbable, a level of engineering compressed into an animal scarcely larger than a dinner plate. Yet within the rivers that shaped it, every curve of bone, every interlocking tooth, and every burst of muscular force fits quietly into the larger logic of survival. Water carries information differently from air. A single drop of blood entering a river does not remain still or localized. It stretches outward through the current in invisible threads, diluted but persistent, moving between roots and suspended sediment, while pressure waves from sudden movement travel beside it. Somewhere within that moving chemistry, a school of piranhas begins to change direction. The feeding frenzy, despite its reputation, is not imaginary. Under the right conditions, it is entirely real, abrupt, and violent in appearance. Yet, the underlying biology bears little resemblance to the coordinated hunt imagined by popular culture. There is no leader within the school directing movement toward prey. No dominant individual organizes the attack. No collective strategy emerges in the way wolves coordinate across snow or dolphins circle through open water. What unfolds instead is something more immediate and more chaotic, a convergence of competing animals responding simultaneously to the same environmental signal. The trigger begins with disturbance. Blood dissolved in water above a certain concentration activates feeding responses through the piranha's chemical detection system. At the same time, erratic vibrations produced by thrashing or injured movement propagate through the river as hydrodynamic signals. The sensory systems described earlier, the lateral line, the acute olfactory structures, the constant reading of pressure and chemistry, suddenly align around a single event. Every nearby fish receives essentially the same message at once. Food is present. Access may disappear quickly. That final detail matters enormously. The frenzy is not cooperation. It is competition, compressed into seconds. Each piranha is attempting to extract tissue before the opportunity vanishes or before neighboring fish consume the available resource first. The school surges not because it is socially coordinated in the sophisticated sense often imagined, but because many individuals are independently accelerating toward the same limited reward. Behavioral ecologists describe this as opportunistic competitive feeding, closer in principle to scavengers converging on a carcass than to organized pack hunting. Experiments conducted under controlled conditions revealed something especially revealing about this behavior. When isolated from the protection of the group, piranhas frequently become hesitant, even around visibly injured prey items. Solitary individuals often refuse to attack if they themselves feel exposed. The confidence associated with the frenzy emerges largely from numbers. Inside a dense aggregation, risk disperses statistically across many bodies. A fish feeding at the edge of collective movement gains not only access to food, but partial protection from predators larger than itself. The school functions as camouflage through mathematics. In the confusion of many overlapping bodies, the probability of any single piranha becoming the target drops significantly. This changes the animal's willingness to approach disturbance. The frenzy, therefore, contains two simultaneous motivations operating together: attraction toward food and protection within the group. Beneath the apparent aggression sits a quieter logic of vulnerability. Even at its most intense, the event remains remarkably brief. Once tissue fragments disperse, once chemical concentration falls, or once movement subsides below a certain threshold, the school loses cohesion almost immediately. The water settles. Fish drift outward, again into looser formation. There is no extended pursuit across long distances, no organized search for additional victims. The behavior terminates itself naturally because the stimulus that produced it dissolves back into the river. Seen closely, the feeding frenzy resembles less a coordinated massacre and more a temporary ecological compression. Many nervous animals colliding around a rare concentration of resources inside environments where competition can become severe during low water periods. The image remains dramatic because dozens of bodies move at once, but the mechanism underneath is rooted not in cruelty or collective bloodlust, only in sensory biology, scarcity, and timing. The mythology transformed the frenzy into evidence of relentless predatory intent. The river tells a quieter story. It describes animals responding rapidly to disturbance, exploiting opportunity while sheltering within the crowd, then dispersing again into the dark current almost as quickly as they arrived. At the surface of many Amazonian channels, the water appears calm enough to conceal danger equally in every direction. Yet for a piranha moving beneath that surface, the river is filled less with prey than with things capable of swallowing it whole. The fish that Western culture transformed into an apex predator spends much of its existence navigating a layered world of hunters, larger, faster, and often far more intelligent than itself. Among the most skilled of these predators is the pink river dolphin, known locally across much of Amazonia as the boto. Inia geoffrensis moves through dark water using echolocation, constructing an acoustic image of the river through bursts of sound that return from submerged objects and living bodies. A schooling fish gains little protection from camouflage against an animal that hunts by echo. Within dense groups of moving piranhas, the botto can isolate individuals with remarkable precision, accelerating suddenly through the school before seizing a target sideways in its jaws. The dolphin's intelligence adds another layer of pressure. These are predators capable of adapting their hunting behavior to season, habitat, and fish density across changing flood conditions. Elsewhere, along quieter stretches of riverbank, giant river otters patrol in family groups. Pteronura brasiliensis is the largest otter species on Earth, reaching lengths of nearly 2 meters from nose to tail. In the water, they move with fluid confidence, surfacing briefly before vanishing again beneath floating vegetation. Researchers filming feeding frenzies have documented giant otters entering the margins of dense piranha activity and extracting fish without hesitation. Their speed and dexterity reduce exposure time so effectively that the feared bite becomes largely irrelevant. To the otter, the piranha is simply another river fish rich in protein. The danger deepens further in slower backwaters where black caimans rest near muddy banks beneath overhanging forest. Melanosuchus niger can exceed 5 meters in length, among the largest predators in the Amazon basin. Young piranhas drifting too close to caiman territories disappear quickly, while adult schools near basking sites remain under constant threat from sudden lunges through shallow water. The river contains few defensive options against an ambush predator of that scale. Schooling offers probability, not certainty. Even the sky participates in this pressure. Large wading birds move through floodplains with extraordinary patience, their reflections trembling across the surface while they remain almost perfectly still. Jabiru storks, kokoi herons, and several egret species take piranhas regularly from shallow margins where fish become concentrated during falling water levels. A single downward strike from a long bill can remove an individual before the rest of the school fully reacts. Survival in such environments depends on constant vigilance from every direction at once. Then there is the arapaima, among the largest freshwater fish on Earth. Arapaima gigas can reach lengths of nearly 3 meters, surfacing occasionally to breathe atmospheric air with a heavy rolling motion that disturbs the surface like distant weather. Its scales form interlocking bony armor, so resistant to cutting that piranha teeth struggle to penetrate them effectively. A predator large enough to consume piranhas while remaining functionally immune to their bite alters the balance of the river entirely. Against such armor, the famed jaw becomes almost insignificant. Humans belong within this list as well. Throughout Amazonia, piranhas are routinely caught, sold, cooked, and eaten. Fresh specimens appear in riverside markets, stacked beside catfish and pecos, their metallic bodies reflecting morning light beneath woven shade roofs. Some are grilled over charcoal fires. Others become soups and stews prepared in communities that have coexisted with these fish for generations. The relationship is practical rather than mythic, woven quietly into daily subsistence. Seen together, this predator landscape changes the entire emotional architecture of the piranha. The tight schools, the rapid alarm responses, the hesitation displayed by isolated individuals, all of it begins to make biological sense. This is not an invulnerable hunter dominating its environment without fear. It is a medium-sized freshwater fish surviving among dolphins, crocodilians, giant otters, towering birds, enormous armored fish, and humans, each capable of turning the hunter into food within seconds. In laboratory aquariums far removed from the flooded forests of South America, researchers began noticing behaviors that seemed strangely incompatible with the mythology surrounding piranhas. The fish often hesitated before approaching unfamiliar spaces. Sudden movement outside the glass produced immediate withdrawal responses. New objects lowered into the water were not attacked impulsively, but monitored cautiously from a distance. In controlled studies examining stress physiology and defensive behavior, the supposed aquatic aggressor repeatedly behaved like an animal, deeply concerned with avoiding danger. Over time, peer-reviewed experiments started building a far more detailed portrait of the piranha's inner life. When exposed to cues associated with predators, piranhas displayed the same behavioral patterns documented across countless prey species throughout the animal kingdom. Schools tightened into dense formations. Individuals froze motionless for extended periods. Feeding activity declined sharply. Escape reactions accelerated. Rather than moving toward threat, the fish directed energy toward concealment, vigilance, and survival. One of the most important mechanisms behind these responses drifts invisibly through the water itself. Ichthyologists use the German term Schreckstoff, meaning roughly fright substance, to describe a chemical alarm signal released from damaged skin cells when a fish is injured. The compound functions almost like a biological warning flare. Once dissolved into the surrounding current, nearby fish detect it through highly sensitive olfactory systems and alter behavior immediately. For piranhas, the response is defensive rather than reckless. Schools compress inward, movement patterns become erratic and evasive. Individuals seek the protection of collective formation. A behavioral study, published in 2012, explored these reactions in more detail by exposing piranha schools to predator odors under controlled conditions. The changes were immediate and measurable. Fish reduced overall movement throughout the tank and spent extended periods orienting themselves toward the direction from which the chemical signal arrived. School cohesion increased significantly, each body narrowing the space between itself and its neighbors. The behavior resembled threat assessment more than aggression, an animal calculating risk within an environment where hesitation and overexposure could quickly become fatal. Even outside formal experiments, aquarium keepers and field researchers frequently observe signs of chronic stress when piranhas are housed improperly or exposed to unstable conditions. Individuals may clamp their fins tightly against the body, reduce feeding activity for days, or retreat into corners away from open water. Elevated cortisol levels, the same broad hormonal stress response seen across vertebrates, appear in fish subjected to persistent disturbance. The mythology suggested emotional simplicity. The biology suggests a nervous system continuously evaluating danger. In natural river systems, these behaviors become even more revealing. Researchers working in Amazonian tributaries repeatedly document piranhas moving away from human swimmers rather than approaching them. Schools disperse under sudden disturbance. Individuals retreat into submerged vegetation or deeper channels when large bodies enter the water nearby. The cinematic image of fish converging eagerly toward every splash becomes difficult to sustain once actual field observations accumulate. Most of the time, the fish are attempting not to be noticed at all. The school itself begins to look different under this lens. Popular culture framed schooling as offensive organization, a coordinated hunting formation advancing through the water with collective intent. Yet, the mathematics behind schooling behavior tells another story entirely. The same statistical logic that drives sardines into dense bait balls beneath the open ocean shapes piranha behavior within rivers and floodplains. A fish positioned near the center of a large moving group dramatically lowers the probability of becoming the individual selected by a predator. Safety emerges not through strength, but through distribution of risk across many bodies. Seen this way, much of piranha behavior reorganizes itself into the psychology of a hunted animal. The vigilance, the sudden evasions, the dense formations, the reluctance displayed by isolated individuals, all of it belongs to a creature living under continuous ecological pressure. The fish transformed by cinema into a remorseless killer spends substantial portions of its daily existence responding to danger signals carried quietly through dark water, navigating the river with the caution of something fully aware that it can disappear at any moment. During the flood season, the forest itself begins falling into the water. Fruit drops from submerged branches with soft impacts against the surface, drifting slowly between trunks while seeds spin through the current beneath layers of floating vegetation. In these months, the rivers become something closer to moving orchards than hunting grounds. And among the fish, feeding quietly through the drowned forest, are close relatives of the piranha, whose diets would have seemed almost impossible to audiences raised on the mythology of flesh and bone. The family Cerassalmidae contains an astonishing range of feeding strategies, extending from specialized carnivores to near-complete herbivores. Beneath the broad silhouette shared across the family tree, compressed bodies, powerful jaws, deep chests built for maneuvering through flooded environments, evolution diversified in multiple directions at once. The razor-toothed piranha became only one branch among many. Some relatives moved steadily toward plant-based diets until the structure of their mouths transformed entirely. The pacu is perhaps the clearest example of this hidden diversity. Colosoma macropomum belongs to the same broader lineage as the red-bellied piranha, yet its feeding behavior feels almost surreal beside the popular stereotype. Adult pacus feed primarily on fruit, seeds, nuts, and aquatic vegetation drifting through flooded forest. Their teeth are broad, flat, and rounded, arranged in rows uncannily similar in appearance to human molars. Photographs of pacu jaws circulated widely across the internet for years because viewers struggled to reconcile those familiar dental shapes with the idea of a South American fish. The resemblance is more than superficial. The same underlying jaw architecture that produced cutting blades in piranhas generated crushing surfaces in pacus, shaped gradually by dietary pressure across evolutionary time. In regions where palm fruits dominate seasonal food availability, pacus have been documented cracking hard nuts with surprising efficiency. The musculature driving the bite remains powerful, but the force is redirected through broad contact surfaces designed to fracture seeds rather than shear flesh. Evolution altered the geometry while preserving the mechanical strength beneath it. Further within the family tree, dietary specialization becomes even more varied. Tomites camunani, formally described by researchers in 2015, feeds almost entirely on river algae and aquatic plants attached to submerged rock surfaces. Its teeth evolved into scraping structures suited for removing layers of biofilm from stone in fast-moving channels. The image of a piranha relative grazing quietly across algae-coated rocks beneath clear current feels almost incompatible with the mythology built around the group, yet biologically it sits firmly within the same lineage. Several species belonging to the genus Mylius display similar tendencies. Dietary analyses examining stomach contents across multiple seasons found plant matter composing the overwhelming majority of their intake, often between 80 and 90%. Leaves, seeds, fruit pulp, aquatic vegetation, and algae dominate digestive samples where popular imagination expected blood and muscle tissue. Even species considered primarily carnivorous shift substantially toward frugivory during seasonal flooding when forest fruit becomes abundant. This seasonal transition transforms the ecological role of many cerasselmids entirely. As fish consume fruit and travel through inundated forest, seeds pass through digestive systems intact and are deposited kilometers away in new locations. Researchers increasingly recognize these species as important seed dispersers within Amazonian floodplain ecosystems. In functional terms, some cerasselmids behave less like predators and more like large fruit-eating birds, transporting plant life across enormous flooded landscapes through ordinary feeding movement. The deeper evolutionary picture becomes increasingly difficult to simplify into any single stereotype. The ancestral template of the family was likely neither an extreme carnivore nor a strict herbivore, but something flexible enough to exploit changing flood cycles and fluctuating food availability across South America's dynamic river systems. From that adaptable foundation emerged many paths simultaneously: flesh eaters, scale grazers, fruit crushers, algae scrapers, omnivores drifting between categories depending on season and habitat. Seen this way, the famous piranha begins to lose some of its imagined isolation. The sharp-toothed hunter remains real, but it exists within a far larger family shaped not by singular violence, but by ecological diversity, evolutionary experimentation, and rivers generous enough to support countless ways of surviving inside them. For part of the year, the Amazon stops resembling a river at all. Water rises silently through the forest floor until tree trunks disappear beneath the surface, and entire landscapes become submerged beneath slow-moving current. Canoes drift between branches that months earlier stood high above dry ground. Fish move through places where monkeys had once crossed overhead. The boundaries between river and forest dissolve completely. This transformation follows a rhythm known as the flood pulse, one of the defining ecological processes of the Amazon basin. Rather than remaining confined within stable banks, the system expands and contracts across immense distances on an approximately 6-month cycle. During the wet season, usually stretching from around November through June in the central Amazon, water levels can rise by as much as 14 meters. Roughly 300,000 square kilometers of surrounding forest become inundated beneath spreading floodwaters. These submerged forests form temporary aquatic worlds of extraordinary complexity. Whitewater floodplains create ecosystems known as varzea, nutrient-rich regions fed by sediment carried from the Andes. Blackwater floodplains form agapo forests, darker and more chemically acidic beneath tannin-stained water. Both environments alter the behavior of nearly everything living inside them. Fish disperse through newly accessible territory, extending for kilometers beneath submerged canopy, while fruit, seeds, insects, and organic debris enter the water in enormous seasonal pulses. For piranhas, this expansion changes almost every aspect of daily life. During flood season, the fish move extensively into the drowned forest, where food becomes abundant and widely distributed. Dense concentrations break apart across millions of hectares of submerged habitat. Competition softens. Encounters become less compressed. Aggression thresholds rise accordingly because scarcity itself relaxes. The piranha navigating flooded forest during high water behaves very differently from the animal trapped later within shrinking dry season channels. Diet changes first. Fruit falls directly into the water from inundated trees, seeds drift beneath branches, insects tumble from flooded vegetation, while invertebrates colonize submerged root systems. Small fish remain part of the menu, but they become one food source among many, rather than the singular focus imagined by mythology. In some floodplain regions, piranhas spend substantial portions of the season feeding on plant material carried through the forest current. The river transforms into a broad nutritional mosaic, and the fish respond with opportunistic flexibility. This season of abundance also becomes the season of reproduction. Among submerged vegetation, piranhas construct shallow nest depressions where adhesive eggs are deposited and protected. Males remain near the nest site, actively guarding, developing eggs against intruders, and fanning them with fin movements that maintain oxygen flow through the water. Territorial behavior emerges around these nesting areas, not as indiscriminate aggression, but as parental investment focused on defending offspring during a vulnerable stage of development. The image of the piranha as a mindless feeding machine leaves little room for this quieter reality, a fish holding position patiently beside its own developing young beneath flooded roots. Then, the cycle reverses. As the dry season arrives, waters begin retreating from the forest. Floodplains contract, channels narrow, temporary lakes shrink steadily beneath increasing heat. Fish populations, once dispersed across enormous landscapes, become concentrated inside isolated pools and crowded waterways where food availability drops sharply. Nutritional stress rises throughout the ecosystem. Competition intensifies again because the river itself is physically compressing life into smaller and smaller spaces. Under these conditions, behavior changes rapidly. Schools tighten, feeding responses accelerate, disturbance thresholds drop. The same species that drifted calmly through submerged forest months earlier now navigates environments shaped by scarcity and confinement. Dry season piranhas are behaviorally distinct animals, not because their anatomy changes, but because the ecological pressures surrounding them shift so dramatically. Patterns of human conflict align with this cycle almost perfectly. Most documented bite incidents occur during low water periods when fish density peaks, resources decline, and people enter increasingly concentrated waterways for swimming, fishing, or bathing. The data follows the flood pulse with remarkable consistency. The river expands, tension softens. The river contracts, competition sharpens. The mythology once treated piranha aggression as permanent and universal. The Amazon reveals it instead as seasonal, ecological, and deeply connected to the changing architecture of water itself. Most documented piranha injuries begin not with dramatic predation, but with ordinary moments unfolding along riverbanks. A fisherman reaches into a crowded net while removing a struggling catch. A child steps barefoot through a shallow pool during low water season. Someone cleans fish near the edge of a channel and leaves scraps drifting into the current. The incidents recorded across Amazonian medical facilities tend to emerge from routines woven deeply into everyday life around the river rather than from sudden cinematic encounters. In the Brazilian state of Amazonas, medical records tracking piranha bite incidents reveal patterns that repeat with striking consistency. The overwhelming majority of injuries occur on extremities, fingers, toes, heels, and the edges of hands or feet. These are body parts entering the water first, moving unpredictably near feeding zones or enclosed pools where fish density becomes unusually high during seasonal contraction. Deep catastrophic wounds, the sort popular culture attached permanently to the piranha image, remains statistically uncommon within the actual clinical data. Victim profiles tell a similarly precise story. Fishermen handling catches directly in the water appear frequently in documented reports. Swimmers already carrying small bleeding cuts or abrasions become more vulnerable under crowded dry season conditions. Children wading through isolated pools during periods of low water account for another recurring category, partly because shrinking habitats compress fish populations into unusually dense concentrations. Incidents also rise near locations where discarded fish remains, blood, or food scraps enter the river. The pattern is ecological rather than random. Specific environmental pressures repeatedly align before bite frequency increases. The event at Lagoa do Piato during 2014 remains one of the clearest examples. International headlines framed the incident as a terrifying mass attack after roughly 70 bathers emerged from the water with bite wounds during a crowded holiday gathering in northeastern Brazil. Yet the details recorded afterward revealed a far narrower and more comprehensible event. Every injury was superficial. Nearly all wounds affected hands, feet, or toes. None proved life-threatening. The lagoon itself had reached critically low dry season levels, concentrating fish into shrinking warm water while increasing nutritional stress across the ecosystem. Bathers had also been throwing food into the water shortly before the incident began, creating precisely the kind of disturbance associated with opportunistic, competitive feeding. The conditions aligned almost perfectly with the behavioral pressures already visible throughout the broader data. Fatal attacks attributed directly to piranhas remain extraordinarily rare. In forensic examinations involving river deaths where piranha wounds are present, investigators often conclude that drowning or prior incapacitation occurred before the fish arrived. Much of the feeding associated with human corpses in Amazonian waterways appears post-mortem, scavenging behavior rather than active predatory killing. This distinction matters biologically because scavengers perform important ecological roles across river systems, removing organic material rapidly from aquatic environments. Placed beside other animals, the statistical contrast becomes even clearer. Hippopotamuses kill hundreds of people annually across parts of Africa. Nile crocodiles are responsible for several hundred human deaths each year as well. In South America, electric eels capable of generating shocks exceeding 800 volts have caused more documented fatalities than piranhas. Yet none of these animals occupy the same exaggerated symbolic position in global imagination. Indigenous Amazonian communities have long approached piranhas with practical caution rather than mythological terror. Seasonal swimming protocols shift naturally alongside water levels. Certain pools and channels are avoided during periods of contraction or near fish cleaning sites. Children learn where and when caution becomes necessary through accumulated ecological knowledge passed quietly between generations. The fish is treated as a manageable hazard within a larger living landscape, neither harmless nor monstrous. The evidence ultimately produces a portrait far more restrained than the stories built around it. Piranhas are capable of inflicting serious injuries under specific environmental conditions. Their jaws deserve respect, particularly in crowded dry season habitats where stress and competition intensify. Yet the data does not support the image of a relentless human predator waiting beneath every Amazonian surface. What emerges instead is an animal whose occasional danger is real, but highly contextual, shaped by season, scarcity, disturbance, and the endlessly shifting architecture of the river itself. Much of the Amazon exists beyond the reach of clear vision. In blackwater tributaries stained dark by tannins, sunlight fades quickly beneath the surface until movement becomes shadow and vibration more than visible form. Fish drifting through these rivers navigate a world where sound and pressure often carry farther than sight. Within that dim environment, red-bellied piranhas do something once considered unexpectedly sophisticated for a fish long dismissed as instinct-driven. They communicate acoustically. Piranhas belong to a relatively small group of fish, species capable of producing deliberate structured sounds associated with specific social situations. For decades, these noises passed largely unnoticed outside aquarium observations, brief clicks and pulses emerging beneath the surface without clear interpretation. Then, in 2011, a research team led by Eric Parmentier at the University of Liège examined the behavior in detail and identified a surprisingly organized vocal system operating within red-bellied piranha groups. The first sound they documented resembled a low repetitive bark. It occurred most often when two piranhas faced one another during territorial disputes or competition around food. The fish circled slowly, bodies held tense, producing short pulses in regular sequence while maintaining distance. The sound functioned less as a declaration of attack than as a warning, a signal communicating agitation before physical escalation became necessary. In many observed encounters, the exchange ended there. One fish withdrew quietly into the school and the confrontation dissolved without injury. A second vocalization emerged during active pursuit. Softer and lower in frequency, the sound resembled a muted drum pulse produced while one individual chased another through confined space. Researchers interpreted it as a behavioral transition signal, something between warning and direct aggression. The fish had moved beyond static display, but had not yet entered actual contact. Even within conflict, the communication remained layered and graded rather than immediate and indiscriminate. The third sound appeared only during biting itself. Rapid clicks accompanied moments of direct physical contact, forming the acoustic signature of actual aggression. By the time these clicks occurred, the earlier stages of warning and pursuit had already failed to resolve the interaction. The progression formed a behavioral sequence with distinct thresholds: bark before chase, chase before bite. The mechanism producing these sounds lies inside the body cavity near the swim bladder, the internal gas-filled organ most fish use for buoyancy control. In piranhas, specialized muscles contract rapidly against the swim bladder wall, vibrating it like a biological drum. Similar systems evolved independently in several fish lineages, yet the precision and behavioral association observed in red-bellied piranhas proved unexpectedly complex. The sounds were not random byproducts of movement. They corresponded consistently with identifiable social states. This discovery altered more than the study of piranha acoustics alone. A graded vocal warning system implies internal social regulation. Animals capable of communicating escalating levels of intent possess opportunities to avoid unnecessary injury. The mythology surrounding piranhas assumed constant readiness for chaotic violence, but the acoustic evidence suggested something almost opposite: a fish frequently attempting to prevent physical conflict through signaling before resorting to force. Experiments and aquarium observations reinforced this interpretation. Given space and opportunity, piranhas often resolved confrontations acoustically without ever biting. Threat displays remained ritualized. Pursuit ended in withdrawal. Sound functioned as a de-escalation mechanism, preserving social stability within crowded groups where uncontrolled fighting would carry serious costs. In tightly packed schools, moving through fluctuating river environments, conserving energy and avoiding injury becomes biologically valuable. Researchers involved in these studies noted openly that the communication complexity surprised them. The fish long treated as a near-mechanical predator displayed behavioral nuance more commonly associated with socially structured animals. Acoustic signaling, conflict negotiation, and context-dependent escalation all pointed toward a richer social life than earlier assumptions allowed. Beneath the surface of dark Amazonian water, then, the piranha world is not silent. Schools drift through flooded channels, accompanied by soft pulses, low barks, and muted vibrations carrying through current and vegetation. Much of their social existence unfolds acoustically inside a river system where sight fades quickly and where survival increasingly depends not on constant attack, but on the ability to communicate before violence becomes necessary. From above, a piranha school can appear almost fluid, less like a collection of individual animals than a single shifting body turning through the water. Hundreds of silver flanks change direction together with such precision that the movement resembles wind altering the surface of grass. Yet beneath that apparent simplicity lies a highly structured system shaped by probability, sensory coordination, and constant negotiation between safety and competition. Researchers studying piranha schooling behavior with underwater cameras and motion tracking systems discovered that these groups are not random gatherings formed accidentally by proximity. Schools maintain recurring internal patterns, stable spacing relationships, and measurable behavioral rules that shift depending on threat level, habitat type, and food availability. A school operates as a dynamic architecture assembled continuously in motion. Its size changes first with season and circumstance. Red-bellied piranhas may travel in groups as small as 20 individuals or in aggregations numbering several hundred. The balance appears surprisingly delicate. Smaller schools provide less protection from predators, while excessively large groups intensify competition for food and increase internal tension. Somewhere between those pressures emerges an optimal size range where collective safety outweighs the costs of overcrowding. The school becomes a living compromise between hunger and survival. Inside that moving structure, not every position carries equal risk. Fish occupying the leading edge or outer perimeter remain statistically more vulnerable to predation. The center offers relative protection because predators striking into dense groups are less likely to isolate any specific individual. Experiments exposing schools to predator cues revealed that piranhas actively compete for central positions when threat increases. Bodies compress inward. Peripheral individuals attempt to move toward the safer interior, while the group tightens around itself, like muscle responding to pressure. What makes this coordination especially remarkable is that it functions even in conditions where vision becomes nearly useless. In dark floodplain channels and tannin-stained black water, piranhas maintain cohesion primarily through the lateral line system rather than visual following. Each fish continuously detects tiny pressure waves generated by neighboring bodies moving through the current. A slight acceleration by one individual propagates outward through the school almost instantly as hydrodynamic information. The group responds collectively without requiring clear sight at all. Biologists studying collective animal motion use the term polarization to describe how aligned the movement of a group becomes at any given moment. Highly polarized schools move in near unison, each body oriented in almost the same direction simultaneously. Piranhas display this strongly during predator avoidance. Under threat, the school sharpens into coordinated motion with remarkable speed. During feeding, however, polarization drops significantly as individuals break formation and compete around concentrated resources. The school shifts continuously between order and disorder depending on ecological context. One of the most extraordinary behaviors appears during encounters with large predators moving directly through the group. Instead of scattering chaotically, piranha schools often divide around the intruding body and reform behind it once the danger passes. The maneuver unfolds within fractions of a second, requiring rapid collective adjustment across dozens or hundreds of individuals simultaneously. Pressure signals ripple through the formation, while fish alter speed and spacing in near-perfect sequence. The school behaves almost like a flexible organism, deforming temporarily around an obstacle before returning to shape. Evidence also suggests these groups are not socially anonymous. Chemical cue studies indicate piranhas can distinguish familiar individuals from strangers within the school. Groups composed of fish, accustomed to one another, display lower levels of internal aggression and more coordinated responses to predator signals than newly assembled collections of unfamiliar individuals. Social familiarity appears to improve collective efficiency, reducing conflict while strengthening defensive behavior. The school therefore performs several functions at once. It is protection against predators. It is a social environment, regulating aggression and communication. It is also a feeding structure, allowing rapid, collective response when resources appear. Three distinct biological roles merge into one constantly shifting formation, carried through rivers where visibility fades quickly and danger can arrive from any direction. Seen this way, the piranha school no longer resembles a mob driven blindly by aggression. It resembles mathematics made alive in water, individual animals solving the problem of survival together through movement, spacing, memory, and the invisible language of pressure waves passing continuously through the current. In some stretches of the Amazon, daylight barely enters the water at all. Beneath overhanging forest and drifting tannins, released by decomposing vegetation, entire channels darken into something closer to liquid amber than a conventional river. Visibility can collapse to less than 30 centimeters even at midday. A fish moving nearby may vanish almost immediately into the stained current, its outline dissolving before shape or color can fully register. Yet piranhas continue navigating these waters with extraordinary precision, locating food, maintaining schools, avoiding predators, and responding to movement long before anything becomes visible to human eyes. Their eyes reveal the first adaptation to this environment. Relative to body size, piranhas possess unusually large eyes, capable of gathering greater amounts of available light through widened pupils and enlarged retinal surfaces. In the dim conditions of black water systems, even slight increases in light sensitivity become biologically valuable. The river rewards anything capable of perceiving motion within darkness fractions of a second earlier than its competitors or predators. Inside the retina itself, rod photoreceptors greatly outnumber cones. Rod cells specialize in low light sensitivity rather than detailed color discrimination, allowing piranhas to detect contrast and movement efficiently under conditions where color becomes almost irrelevant. Shapes emerge before hues do. A slight flicker of movement against the surrounding dark may carry more survival value than precise visual detail. The fish is tuned for detection first, interpretation second. Yet this visual system remains surprisingly flexible across the Amazon basin. In clearer whitewater rivers carrying suspended Andean sediment, piranhas demonstrate improved color discrimination compared with populations inhabiting darker, blackwater habitats. Researchers studying these differences have identified measurable variation in sensory development linked directly to environmental conditions, an example of phenotypic plasticity unfolding across river systems. The same species adjusts aspects of its sensory architecture according to the optical world surrounding it. Even so, vision alone cannot explain how piranhas move so effectively through near total darkness. Their dominant sensory system under low visibility conditions is the lateral line, a network of thousands of microscopic hair cell receptors extending along the surface of the body. These receptors detect minute changes in water pressure and displacement at astonishingly fine scales. A nearby fish turning suddenly, an insect struggling against the surface, or the slow passage of a predator through submerged roots all generate hydrodynamic disturbances carried outward through the water. To the piranha, these pressure waves form a continuous sensory map. Direction, speed, body size, and distance can all be estimated without direct visual contact. Schools maintain cohesion through these signals, even when the river becomes entirely opaque. Individual fish align themselves through invisible patterns of movement transmitted physically through current rather than through sight. The surrounding water becomes not empty space, but an information field constantly shifting around the body. A third sensory channel operates more quietly still. Piranhas possess electroreceptive structures related to the ampullae of Lorenzini, seen more prominently in sharks. Though less developed, these organs allow detection of weak bioelectric fields generated by living organisms. Every muscle contraction and nerve impulse produces faint electrical activity. In dark water where vision falters completely, such signals provide additional awareness of nearby life moving through the current. Their chemical sensitivity adds another layer to this already dense sensory world. Olfactory tissues within the nasal cavities detect dissolved biological compounds at remarkably low concentrations. Blood, damaged tissue, stress chemicals released by injured fish, and organic traces drifting downstream all carry information. These signals connect directly to brain regions associated with feeding and behavioral response. Long before visual confirmation occurs, chemistry may already have altered the fish's behavior. Taken together, the complete sensory picture becomes far stranger and more sophisticated than the old mythology ever suggested. A piranha suspended within total darkness is not isolated or blind. It continues, receiving a high-resolution stream of information through pressure, electricity, and chemistry simultaneously. Nearby bodies announce themselves through vibrations. Living tissue emits faint electrical signatures. Water itself carries dissolved traces of movement and injury downstream like invisible smoke. The Amazon River, opaque to human perception, remains densely alive with signals. Within that darkness, the piranha moves through a world assembled not from sight alone, but from overlapping sensory systems layered together into something closer to constant environmental awareness. A fish reading the river through means far older and more intricate than vision by itself could ever provide. Long before the Amazon carried its modern course across South America, before flooded forests spread seasonally beneath tropical rain, the lineage that would eventually produce the piranha already existed in older freshwater systems shaped by drifting continents and changing seas. Its ancestry belongs to the order Characiformes, a vast group of freshwater fishes distributed primarily across South America and Africa, their evolutionary history tracing back toward the breakup of the ancient supercontinent Gondwana. As those continental masses separated over immense geological time, river systems isolated populations from one another, allowing entire radiations of freshwater fish diversity to unfold independently on opposite sides of the Atlantic. The piranha branch emerged much later within that broader history. The oldest confirmed fossils attributable to piranha relatives date to the Miocene epoch, roughly 25 million years ago, recovered from deposits in regions that are now Venezuela and Colombia. Their teeth already carried the familiar triangular architecture recognizable in modern species, though the surrounding ecosystem looked profoundly different from the present Amazon basin. Much of northern South America consisted of wetlands, shallow inland seas, and evolving drainage systems, still unsettled by tectonic upheaval. What these early fossils suggest most strongly is not ancient hyper-aggression, but evolutionary flexibility. The common ancestor shared by piranhas, pecas, silver dollars, and other serrasalmids was likely omnivorous or even primarily herbivorous. The specialized flesh-shearing behavior associated with modern carnivorous piranhas appears to have evolved later as one branch within a much broader dietary diversification. In geological terms, the highly carnivorous piranha is a relatively recent experiment rather than the original template of the family. At the same time, the Amazon itself remained unfinished. The modern eastward-flowing river system, draining into the Atlantic, formed only around 10 million years ago after uplift of the Andes dramatically reorganized South American hydrology. Before that transformation, many western drainage patterns flowed toward the Pacific or emptied into vast inland wetlands. As mountain building altered elevations across the continent, rivers reversed course, merged, fragmented, and created entirely new ecological corridors across northern South America. For freshwater fish, these changes carried enormous evolutionary consequences. New basins formed, while older waterways became isolated from one another. Populations separated geographically over thousands or millions of years gradually diverged genetically. During later Pleistocene climatic fluctuations, alternating wet and dry periods repeatedly expanded and contracted aquatic habitats, creating additional cycles of isolation and reconnection. Speciation accelerated within these shifting networks of rivers, lakes, floodplains, and forest channels. The piranha lineage diversified rapidly within this unstable landscape. Different species adapted to varying water chemistry, food availability, and habitat structure across newly separated systems. Some evolved stronger cutting dentition suited for opportunistic carnivory. Others moved toward fruit consumption, seed crushing, or algae feeding. Evolution did not produce a single inevitable direction. It generated branching ecological experiments unfolding simultaneously across the basin. Their body shape reveals another layer of this process. The deep-bodied, laterally compressed form, common among serrasalmids, appears repeatedly throughout the family tree, even among lineages not closely related. Evolutionary biologists recognize this as convergent evolution, the independent emergence of similar anatomical solutions under similar environmental pressures. In structurally dense flooded forests, filled with submerged roots, branches, and vegetation, a flattened, agile body capable of rapid directional change provides clear advantages. The Amazon shaped these fish repeatedly toward the same general architecture because the environment consistently rewarded it. Genetic studies known as molecular clock analyses provide further insight into timing. By comparing accumulated mutations across related species, researchers estimate that the split between carnivorous piranhas and herbivorous pecas occurred roughly 10 to 12 million years ago, almost precisely during the period when the Amazon basin itself underwent its greatest geological reorganization. As rivers transformed, so did the evolutionary pathways of the animals living inside them. Seen across this scale of time, The piranha becomes something very different from the primordial monster imagined by modern mythology. It is not an unchanged relic from deep prehistory waiting eternally beneath tropical water. It is a comparatively recent product of continental upheaval, climate fluctuation, river reversal, and ecological experimentation. The fish emerged from landscapes, still actively becoming themselves, shaped not by a singular destiny toward violence, but by millions of years of adaptation inside one of the most geologically dynamic freshwater systems on Earth. As floodwaters begin spreading through the forest each year, the behavior of piranhas changes almost imperceptibly at first. Schools loosen slightly within the newly expanded habitat. Individuals move through submerged roots and vegetation with less feeding tension than during the dry season months. Water temperatures rise gently beneath the canopy. Organic material drifts through the current, and the river enters the biological phase that many Amazonian species depend upon for reproduction. For piranhas, this seasonal transformation signals the beginning of courtship. Males begin pursuing females through slow circling movements inside the flooded vegetation. The interactions are measured rather than frantic, bodies turning gradually through the water while low drum-like sounds pulse softly from the swim bladder muscles, already known from territorial communication. The same acoustic system used earlier to regulate aggression now shifts into a different role entirely. Sound becomes part of mate attraction, woven into movement and spacing beneath the surface where visibility remains limited. Once a pair forms temporarily, the male selects a nesting site among submerged plants, fine root systems, or dense aquatic vegetation protected from strong current. Using repeated body movements, he clears a shallow circular depression along the river floor. The nest itself remains modest, often only 15 to 30 centimeters across. Yet within the flooded forest, these small, cleared spaces become carefully defended territories, suspended beneath drifting leaves and branches. Females deposit adhesive eggs directly onto the vegetation within the nest. Depending on body size, age, and nutritional condition, a single clutch may contain anywhere from several hundred to several thousand eggs. Their surfaces cling tightly to submerged plant matter where oxygen-rich water can continue circulating around them. Once deposition ends, the female gradually withdraws from the immediate area while the male remains behind. This is the part of the piranha story rarely included within mythology. The male becomes a parent. For the next several days, he guards the nest continuously, positioning himself near the eggs and driving away intruders that drift too close. Fish considerably larger than himself may be chased from the area through sudden bursts of movement and warning displays. His fins move rhythmically through the water, fanning the eggs to maintain oxygen flow and prevent sediment from settling across their surfaces. The same jaws once exaggerated into symbols of indiscriminate violence now defend a cluster of developing embryos hidden among flooded roots. At Amazonian water temperatures, incubation proceeds rapidly. Within roughly 2 to 3 days, the larvae emerge from their eggs, tiny, translucent bodies carrying yolk reserves that sustain them during the earliest stage of life. They remain close to the nesting area, under continued paternal supervision, while gradually developing the ability to feed independently. The beginning of piranha life bears almost no resemblance to the adult form feared in popular imagination. Juveniles do not emerge as miniature predators. Their first diet consists primarily of microscopic zooplankton and suspended single-celled organisms drifting through the water column. The future owner of razor-edged teeth begins instead as a delicate filter feeder, gathering nearly invisible life from the flooded forest around it. Young piranhas survive largely through concealment. Their early coloration includes spotted patterns that break apart the outline of the body among aquatic plants and shifting light. Rather than occupying open channels, juveniles remain hidden within dense vegetation where larger predators struggle to maneuver efficiently. Every stage of early life unfolds under extreme predation. Pressure from fish, birds, reptiles, and even larger piranhas. Survival depends less on aggression than on remaining unnoticed long enough to grow. Growth proceeds quickly once feeding stabilizes. Under favorable conditions, maturity may arrive within 1 to 2 years, unusually rapid by vertebrate standards. In the unstable world of Amazonian flood cycles, accelerated maturation provides an evolutionary advantage. Life expectancy remains uncertain. Rivers change constantly, predators remain abundant, and seasonal conditions can shift with remarkable speed. Reproducing early improves the chances that genes pass forward before drought, predation, or environmental disruption intervene. Viewed closely, the reproductive life of the piranha reveals an animal organized not around endless destruction, but around continuity. Courtship, nest building, parental defense, camouflage, and juvenile vulnerability all exist beneath the mythology, almost unnoticed. The fish, portrayed for generations as a symbol of mindless appetite, spends part of every year performing something quieter, guarding fragile new life inside the flooded forest while the river slowly rises around it. A river as vast as the Amazon remains stable only because countless organisms perform quiet forms of labor beneath the surface. Some consume algae from submerged roots. Some carry seeds between flooded forests. Some recycle dead material before disease can spread through warm, stagnant water. The piranha belongs to this hidden workforce. Its ecological importance becomes clearest not when examining the fish in isolation, but when imagining the river system without it. As both predator and scavenger, the piranha occupies a middle position within the Amazonian food web, linking energy between smaller organisms below and larger predators above. One of its most significant functions involves carrion removal. Injured fish, drowned animals, and organic remains entering the water are consumed rapidly, accelerating nutrient recycling through the ecosystem. In tropical conditions where heat and moisture intensify bacterial growth, this process matters enormously. Organic material does not linger long beneath the surface. Nutrients, locked inside dead tissue, return quickly into the living system through digestion and excretion. This role extends beyond simple feeding. By reducing the amount of decaying matter suspended within isolated pools and floodplain channels, scavenging fish help limit pathogen accumulation in crowded aquatic environments. The piranha becomes part of the river's sanitation system, transforming death back into biological circulation before decomposition destabilizes local conditions. Some species within the broader piranha lineage evolved even more specialized strategies. Lepidophagy, the consumption of scales from living fish, appears among several serrasalmid species inhabiting South American waterways. Rather than attempting to kill prey outright, these fish approach larger animals from behind and remove individual scales with rapid sideways strikes. The scales themselves contain collagen, lipids, and mineral nutrients valuable enough to support this unusual feeding adaptation. The behavior alters the ecology of prey fish populations in subtle ways. Fish vulnerable to scale feeding often develop thicker armor, faster escape responses, or altered schooling patterns over evolutionary time. Predator and prey enter a slow biological dialogue carried across generations, each influencing the anatomy and behavior of the other. The piranha family participates not only in consumption, but in shaping the evolutionary pressures surrounding it. Fin feeding introduces another layer of complexity. Certain species selectively remove pieces of fin tissue from living fish without killing them. The effect resembles parasitism more than predation. Damaged fins may reduce swimming efficiency, alter escape performance, or increase vulnerability to larger predators. Yet because fin tissue can regenerate, the interaction becomes strangely sustainable, repeated harvesting rather than terminal attack. During flood season, the ecological role of many piranha relatives changes again. Frugivorous species consume fallen fruits drifting through submerged forests, swallowing seeds along with soft plant tissue. These seeds later pass through the digestive tract and are deposited elsewhere across the floodplain, sometimes kilometers from their original source. In this way, fish become agents of forest regeneration. Tree populations spread genetically through the movements of aquatic animals, navigating temporary flooded habitats. The nutrients released by piranhas themselves continue this cycle. Excretion introduces concentrated nitrogen and phosphorus into floodplain environments that are often relatively nutrient poor. Within submerged forests, these contributions may stimulate local productivity, feeding microbial communities, aquatic plants, and smaller organisms lower in the food chain. The fish participates continuously in chemical exchange between forest and river. At the same time, piranhas remain essential prey for larger predators inhabiting the basin. River dolphins, giant otters, black caimans, large birds, and enormous fish all depend partly upon them as a reliable food source. Energy moving upward through the ecosystem frequently passes through piranha populations first. Remove enough piranhas from the river, and the effects would ripple outward across multiple trophic levels simultaneously. The mythology portrayed the piranha as a destabilizing force, an aberration of violence lurking inside the Amazon. Ecology reveals something almost opposite. The fish helps clean the river, redistribute nutrients, shape prey populations, disperse forest seeds, and sustain predators above it. Its role is not peripheral, it is structural. Beneath the shifting floodwaters, the Amazon functions through interdependence so dense that no species exists alone for long. The piranha, for all the fear projected onto it, remains one of the many organisms quietly holding that immense living system together from within. Not every piranha attempts to overpower prey through direct attack. Some evolve strategies far stranger and more delicate, behaviors so specialized that they seem almost improbable at first glance. In certain South American waterways, a fish may pass through a school apparently unharmed while carrying the evidence of an encounter in the form of missing scales or clipped fins, tiny fragments removed with surgical precision from a body otherwise left alive. These feeding methods belong to some of the most unusual ecological adaptations within the entire piranha family. Lepidophagy, the consumption of scales, represents one of these specialized paths. Scale eating appears in several pseudosalmid species and requires an extraordinary degree of timing and spatial control. Rather than pursuing prey head-on, the attacking fish approaches from behind or slightly below the target, moving carefully toward the lateral flank where detection becomes more difficult. Then, within a fraction of a second, the predator delivers a rapid, sideways strike designed not to kill, but to shear away individual scales from the surface of the body. The targets are often much larger fish, species too fast or physically robust to overpower completely. Their scales, however, provide a concentrated source of nutrition rich in collagen, calcium phosphate, and lipids. During periods when other food becomes scarce, These structures carry enough energetic value to support an entire feeding strategy built around selective harvesting rather than total consumption. Executing such maneuvers demands remarkable precision. Fish possess highly sensitive lateral line systems capable of detecting pressure disturbances generated by approaching bodies in the water. A poorly aligned approach risks immediate detection and escape. Scale-feeding piranhas therefore enter from specific angles, frequently behind and below the target, where hydrodynamic signals remain weaker. The strike itself depends upon exact positioning and timing, jaws closing sideways across the body's surface before the larger fish can fully react. This behavior has shaped prey species over evolutionary time. In regions where scale feeding occurs regularly, many targeted fish display thicker scales, faster directional changes, and increasingly erratic escape movements compared with related populations living elsewhere. Comparative anatomical studies reveal measurable differences linked directly to predation pressure. Predator and prey continuously modify one another through countless generations, each adaptation answered gradually by another. Fin feeding adds yet another layer to this strange ecological relationship. Instead of removing scales, certain species target soft fin tissue from living fish. Fins contain substantial protein resources and, importantly, possess the capacity to regenerate after injury. The result resembles a form of repeated biological harvesting more than conventional predation. A fish may survive multiple encounters while carrying partially regrown fin edges shaped by earlier attacks. The consequences still matter. Damaged fins alter swimming efficiency and maneuverability, potentially reducing the ability of prey fish to evade larger predators or compete successfully within schools. Yet because the victim often survives, the relationship occupies an unusual ecological space somewhere between predation and parasitism. Few other feeding strategies within freshwater fish communities operate quite this way. These specialized behaviors reveal something fundamental about piranha cognition and motor control. The old mythology imagined indiscriminate biting, driven purely by reflexive aggression. Scale feeding and fin feeding require almost the opposite qualities. The fish must assess body orientation, closing speed, hydrodynamic disturbance, and strike geometry continuously in real time. Mistiming by even a small margin may waste valuable energy or expose the attacker to injury from larger prey. There is also restraint built into the behavior. The objective is often not annihilation but efficiency, extracting nutrient-rich material while minimizing risk. The piranha becomes less like a reckless attacker and more like a highly adapted opportunist, exploiting narrow ecological openings inside crowded river systems. Within the Amazon, evolution repeatedly rewards organisms capable of occupying unusual niches. Some animals consume fruit floating through flooded forests. Some detect electricity in opaque water. Some feed upon scales removed one by one from the bodies of larger fish moving through the current beside them. The piranha family contains all of these possibilities simultaneously. Seen closely enough, scale feeding and fin feeding no longer appear grotesque or excessive. They appear mathematically precise, the product of millions of years refining body angle, timing, sensory processing, and jaw mechanics into strategies almost invisible in their speed. Beneath the surface, the river continues generating forms of survival far subtler than the myths ever allowed. Long before the piranha became a creature of sensational headlines and cinema posters, it already existed as something quieter and far more practical within the daily life of Amazonia. Along riverbanks shaded by flooded forest, generations of indigenous communities learned the rhythms of the fish through direct experience, not through spectacle. The relationship that emerged was neither blind fear nor romantic admiration. It was familiarity shaped by observation, caution, and continual coexistence inside one of the most biologically dense environments on Earth. Among many Amazonian peoples, the piranha was understood first as a useful animal. The jaws, once dried, formed naturally serrated cutting tools whose efficiency required almost no modification. Rows of interlocking teeth became blades capable of slicing through plant fibers, trimming hair, preparing fish, and scarifying skin during ritual practices. The structure that later entered Western imagination as a symbol of horror functioned for thousands of years as an ordinary tool integrated into daily material culture. Archaeological excavations across pre-Columbian habitation sites repeatedly uncover these preserved jaws among food remains, pottery fragments, and household debris. Some date back several thousand years, making piranha jaw tools one of the more consistent faunal artifacts recovered from ancient Amazonian settlements. Their persistence across time suggests not novelty, but reliability, a technology simple enough to emerge repeatedly wherever humans and rivers occupied the same landscape. The fish itself also remained an important source of food. Throughout Amazonia, piranhas are caught using baited hooks, woven nets, and traditional bow fishing techniques. Their willingness to bite makes them dependable targets for riverine communities dependent upon local protein sources. In markets scattered along tributaries and floodplain towns, piranhas continue to appear smoked, dried, grilled over charcoal, or simmered into soups whose bones release rich mineral broth into the water. The animal feared abroad often occupies the role of ordinary meal at home. Knowledge surrounding danger developed with equal precision. Indigenous communities did not imagine rivers as harmless, yet neither did they abandon them in terror. Instead, generations accumulated detailed seasonal understanding concerning when aggression risk increased and when the fish remained largely indifferent to human presence. Low water during the dry season, areas where fish scraps entered the river, stagnant pools cut off from larger channels, and zones surrounding feeding caimans all carried greater caution. Behavior adapted accordingly. Swimming locations changed, fishing routines shifted. Children learned these patterns early, through observation and oral teaching, woven quietly into everyday life. Within several Amazonian cosmologies, the piranha also acquired symbolic meaning connected to transformation and risk inside productive environments. The fish represented a reality familiar to rainforest societies, the understanding that nourishment and danger frequently occupy the same physical space. Rivers provide transport, water, fish, fertile floodplains, and at times injury or death. The piranha fit naturally inside this larger ecological logic, neither demon nor hero, but part of the living complexity surrounding human existence. The Munduruku people of the Tapajos River maintain particularly sophisticated distinctions among piranha species. Their classifications separate fish according to habitat preference, behavior, body form, aggression level, and seasonal activity. Such taxonomies emerged not from laboratory analysis, but from accumulated generations of direct ecological interaction. Different species carry different reputations and require different responses, a recognition often flattened entirely within foreign portrayals that reduce every piranha to the same exaggerated caricature. What becomes increasingly visible through indigenous knowledge is the depth of observational intimacy developed over thousands of years. The fish was never abstract. It was encountered while swimming, fishing, preparing meals, traveling flood channels, and navigating seasonal changes in water level. Knowledge formed slowly through repetition and survival rather than through isolated demonstrations arranged for spectacle. The contrast with the mythology later exported through books and films becomes difficult to ignore. One worldview emerged from continuous coexistence inside the Amazon itself. The other emerged largely from distance, selective storytelling, and repetition detached from ecological reality. Between them lies an enormous divide, not merely in interpretation, but in the entire way knowledge about the natural world is created and carried forward across generations. Far from the flooded forests that shaped them, piranhas now drift through scattered waterways on multiple continents, carried not by ancient river systems or tectonic change, but by glass aquariums, plastic transport bags, and the strange global appetite for owning dangerous things. The journey from Amazon tributary to suburban pond or urban canal has become one of the more unusual ecological migrations of the modern age, built almost entirely through human fascination with the mythology surrounding the fish. In Florida, isolated captures of red-bellied piranhas have appeared repeatedly across decades. Individuals have been recovered from canals connected to the Everglades drainage system, from artificial lakes, and from warm southern waterways capable of briefly supporting tropical species. Surveys conducted by fisheries authorities have not confirmed a permanently established breeding population, yet the pattern continues with enough consistency to reveal ongoing release pressure from aquarium ownership. A fish appears, is removed, and then another surfaces years later somewhere else in the same vast network of warm canals and slow-moving freshwater. The story repeats in other regions. In Bangladesh, fishermen working the Karnafuli River in the early years of the 21st century began pulling unfamiliar fish from the water, compact silver bodies carrying the unmistakable jaw structure associated with South American piranhas. Many local communities had no prior cultural knowledge of the species. The source of introduction was never conclusively identified, though aquarium release remains the most widely suspected pathway. Once present, the fish adapted quietly to the river system, entering local fisheries before scientists fully understood the scale of the population. Across Texas, wildlife agencies have documented repeated captures from reservoirs and river systems where released aquarium animals survived long enough to draw official concern. Texas Parks and Wildlife eventually classified piranhas among prohibited exotic species, partly because of ecological uncertainty and partly because of the persistent difficulty of preventing release by private owners. Confiscations from the aquarium trade became routine enough to form their own administrative category. The mechanism driving all of this is remarkably simple. Juvenile piranhas sold in pet stores appear manageable at first, small enough to fit comfortably inside ordinary tanks, their metallic scales and red throats carrying the visual appeal of something forbidden. Over time, however, the fish grow larger, more territorial, and increasingly difficult to house properly. Aquarium owners, unprepared for adult size or long-term care, sometimes release them into local waterways, imagining that a nearby canal or reservoir offers a humane alternative to euthanasia. The result is a slow, scattered dispersal of Amazonian predators into ecosystems that never evolved alongside them. Climate imposes an important limit upon this expansion. Piranhas are tropical freshwater fish whose physiology depends upon relatively warm water temperatures. Sustained exposure below roughly 15 degrees Celsius becomes lethal, preventing permanent survival across much of North America and Europe. Winter cold acts as a natural ecological barrier in many temperate regions, killing released fish before populations can establish stable breeding cycles. This thermal dependence explains why sightings cluster disproportionately in subtropical zones where warm water persists longer through the year. Yet, ecological concern remains legitimate wherever climate conditions resemble portions of tropical South America. In biodiverse waterways, such as southern Florida, a successfully breeding piranha population could potentially alter local fish communities in complex ways. Their sensory systems, rapid feeding responses, and competitive opportunism evolved within ecosystems dense with rivals and predators. Introduced into unfamiliar environments lacking those same evolutionary pressures, the balance could shift unpredictably across native species, already stressed by pollution, habitat fragmentation, and other invasive animals. There is a strange symmetry hidden within this global spread. The same mythology that exaggerated the piranha into an unstoppable aquatic menace also transformed it into a commercially desirable pet. Fear became marketing. Hollywood imagery, sensational books, and decades of repetition produced an animal people wanted to own precisely because it seemed dangerous. The worldwide movement of piranhas through aquariums and accidental release is therefore not separate from the myth at all. It is one of the myth's most tangible ecological consequences, carried outward river by river through the ordinary mechanics of human fascination. Inside the dim water of the Amazon, much of piranha life unfolds beyond ordinary human perception. Signals pass chemically through the current, pressure waves ripple outward through flooded forest, and brief acoustic pulses move between fish in darkness, thick with suspended tannins. For much of the last century, the prevailing mythology left little room for the possibility that any sophisticated inner processing existed beneath the animal's hard triangular teeth. The piranha was imagined as instinct without nuance, appetite without cognition. Yet as behavioral research expanded, that image began to fracture in quiet and increasingly measurable ways. One of the more revealing discoveries emerged from examination of the piranha brain itself. Relative to overall body size, the telencephalon, the forebrain region associated invertebrates with learning, memory, and behavioral integration, is proportionally larger than in many freshwater fish occupying similar ecological niches. The significance of this becomes clearer when placed beside observed behavior. The animal is not merely reacting to isolated stimuli. It appears capable of retaining information, adjusting responses over time, and modifying behavior according to social and environmental context. Chemical cue experiments provide some of the strongest evidence for this complexity. Within schools, piranhas behave differently around familiar individuals than around strangers. Groups composed of fish that have previously lived together show lower internal aggression, tighter schooling coordination, and more stable collective movement patterns. Unfamiliar fish introduced into established groups often trigger heightened tension and defensive spacing before gradual integration occurs. Such behavior implies more than reflexive attraction to movement. It requires memory formation, recognition systems, and a rudimentary form of social categorization maintained over time through chemical identification. Associative learning studies deepen the picture further. In controlled laboratory settings, piranhas repeatedly exposed to specific visual shapes, vibrations, or acoustic cues linked with feeding events begin altering their movement before food arrives. They learn patterns. Some individuals approach rapidly after recognizing the cue, while others maintain more cautious strategies shaped by prior outcomes. Researchers observing these experiments describe measurable behavioral flexibility rather than rigid automatic response. The fish adjust according to experience, retaining learned associations across repeated trials. Equally revealing is the balance piranhas display between caution and curiosity. When unfamiliar objects enter aquarium environments, piranhas rarely rush immediately toward them. Instead, schools often freeze temporarily, tightening formation while individuals maintain distance and observe. Gradually, a few fish begin cautious investigation, approaching and retreating in repeated arcs before the group collectively relaxes. Behavioral ecologists describe this pattern as neophobia, moderated by exploratory assessment, a strategy common among animals navigating environments where novelty may represent either opportunity or danger. Social learning among juveniles introduces another layer of complexity. Young piranhas, raised alongside experienced adults, acquire efficient feeding behavior more rapidly than juveniles isolated from older fish. They learn positioning within schools, response timing during feeding competition, and effective approaches toward prey items through observation and interaction. Some behavioral information, therefore, appears transmissible socially rather than emerging entirely from fixed instinctive programming. The school functions not only as protection, but also as an environment where behavioral patterns propagate across generations. No evidence suggests anything resembling tool use, nor would such behavior be expected from a fish shaped by the ecological pressures of Amazonian rivers. Intelligence expresses itself differently here. It appears in the precision geometry of scale feeding strikes executed against moving targets. It appears in acoustic warning systems that often resolve conflict without injury. It appears in individual recognition, adaptive learning, and the ability to integrate multiple streams of sensory information simultaneously while navigating low visibility water, dense with predators and competitors. What emerges from modern research is not an image of exceptional genius, but of meaningful cognitive sophistication carefully suited to the demands of the Amazon basin. The piranha occupies a world requiring constant interpretation of pressure signals, chemical traces, seasonal shifts, predator threats, and rapidly changing social conditions. Survival inside such an environment rewards flexibility rather than blind aggression. For decades, serious investigation into piranha cognition remained strangely limited because the mythology surrounding the fish discouraged deeper curiosity. Once an animal becomes culturally flattened into a symbol of mindless violence, its complexity begins disappearing from public imagination long before it disappears from the science itself. By the late 20th century, the piranha had become more than an animal. It had become a commercial identity, exported through films, tourism campaigns, aquarium catalogs, paperback thrillers, and sensational television documentaries. The fish drifting through Amazon tributaries now also drifted through a global economy built upon fear, fascination, and repetition. Once the mythology acquired financial value, it began sustaining itself with remarkable durability. Cinema played a central role in this transformation. The release of the original horror film Piranha in the late 1970s translated Roosevelt's earlier narrative into modern mass entertainment, replacing scientific ambiguity with certainty and exaggeration. Sequels, remakes, and reinterpretations followed across decades. By the time multiple franchise entries had circulated internationally through theaters, home video, and streaming distribution, cumulative revenues had climbed into the hundreds of millions of dollars. Each new adaptation reinforced the same simplified image: razor-toothed swarms stripping flesh from living bodies in moments of chaos and panic. Accuracy mattered less than recognizability. The myth had become financially dependable. The aquarium trade discovered similar value and reputation. Juvenile red-bellied piranhas, small enough to fit comfortably within standard tanks, entered global pet markets, carrying the appeal of danger in miniature form. Retail prices varied widely, yet the marketing language surrounding them remained strikingly consistent. Customers were not simply purchasing tropical fish. They were purchasing proximity to a creature already famous for violence. Without the mythology, the commercial appeal of the species would almost certainly contract dramatically. Thousands of peaceful freshwater fish exist with comparable coloration and easier care requirements. What separated the piranha commercially was narrative. Across Amazonian, Brazil, Peru, and Bolivia, tourism industries integrated the same mythology into river excursions, marketed explicitly around controlled encounters with the world's most feared fish. Visitors arriving from Europe and North America paid premium rates for guided piranha fishing trips, often expecting danger before discovering that catching the fish usually involved little more than baited hooks lowered into calm river water. The experience remained profitable because the mythology preceded the reality. The anticipation itself became part of the commodity being sold. Yet the financial benefits generated by this image distribute unevenly. Entertainment companies, tourism operators, and international aquarium suppliers capture most of the economic value associated with the fish's reputation. Indigenous and riverine communities who have lived alongside piranhas for centuries, using them as food and tools within functioning ecological relationships, receive little direct benefit from the global narrative constructed around them. The mythology extracts symbolic value from Amazonian ecosystems while directing most revenue outward toward foreign industries. The consequences extend beyond economics into conservation itself. Animals perceived primarily as dangerous tend to attract less public empathy and weaker political support for habitat protection. Conservation campaigns function partly through emotional connection, and the piranha's reputation has historically made such connection difficult. While charismatic mammals and brightly colored birds often become ambassadors for ecosystem preservation, piranhas remained culturally trapped inside horror imagery. The result is subtle but significant. Public willingness to support freshwater habitat protection rarely intensifies around animals widely imagined as monsters. Scientific research priorities were shaped by the same pressures. For decades, funding and media attention flowed disproportionately toward studies focused upon aggression, bite force, and feeding frenzy behavior because those subjects aligned with existing public fascination. Ecology, cognition, reproductive biology, and conservation dynamics received comparatively less attention despite being equally important for understanding the animal's actual role within the Amazon basin. The mythology influenced not only entertainment, but also the architecture of scientific curiosity itself. What emerges from all this is a clearer understanding of why the myth persists so stubbornly despite mounting biological evidence contradicting its more extreme claims. The narrative survives because it remains commercially efficient. Fear sells tickets. Fear sells aquarium fish. Fear sells tourism experiences and television specials and sensational headlines. Entire industries formed around maintaining the image. Correcting the mythology, therefore, requires more than presenting accurate science. It requires pushing against an economic structure that continues rewarding exaggeration long after the underlying biology has become far more complicated, subtle, and interesting than the old story ever allowed. At the edge of many Amazonian rivers, the forest no longer reaches the water in an unbroken wall. Open scars interrupt the canopy. Smoke drifts upward from cleared ground, and channels once shaded by flooded trees now lie exposed beneath direct equatorial sunlight. Beneath the surface, the changes continue in quieter forms. Altered sediment flow, disrupted breeding grounds, contaminated tributaries, and water cycles no longer moving with their historical rhythm. The piranha, long imagined as an unstoppable force within the Amazon, now exists inside an ecosystem undergoing sustained transformation on a continental scale. Much of the animal's life depends upon habitats that disappear when the surrounding forest is removed. The Varzea and Igapo floodplains, seasonally inundated forests shaped by the annual flood pulse, provide critical breeding areas, feeding territory, nursery habitat for juveniles, and access to the fruiting cycles that support both herbivorous and omnivorous serrasalmids. During high water, piranhas disperse through submerged forest corridors rich with insects, seeds, fallen fruit, and sheltering vegetation. When deforestation strips these systems away, the river remains, but the ecological architecture supporting the fish begins collapsing around it. Between the mid-1980s and the year 2020, the Brazilian Amazon lost roughly 513,000 square kilometers of forest cover, an area larger than Spain. The pace accelerated significantly during portions of the 2010s as logging, cattle expansion, mining, and infrastructure development pushed deeper into previously intact regions. Each removed section of forest alters water chemistry, sediment transport, local temperature, and flood behavior. For a fish whose reproduction and feeding patterns evolved around predictable seasonal inundation, these changes are not abstract environmental statistics. They are direct biological pressures acting upon every stage of life. Fishing pressure adds another layer of strain. Across densely populated river corridors, piranhas remain heavily harvested for food and local commerce. In many regions, reliable population surveys barely exist, making evidence-based catch limits difficult or impossible to establish. Some species likely remain abundant across broad areas of the basin, while others may already be declining locally without comprehensive monitoring capable of detecting the pattern. The sheer scale of the Amazon complicates nearly every conservation effort. Entire tributaries remain poorly studied despite supporting communities that depend upon them daily. Mercury contamination from artisanal gold mining introduces one of the more insidious threats. Across mining regions, mercury used during extraction processes enters river systems directly, dispersing through sediment and food webs. Because piranhas occupy mid-level predatory roles and consume substantial quantities of smaller fish, mercury accumulates progressively within their tissues over time through bioaccumulation. Studies conducted in mining-affected waterways have identified mercury concentrations exceeding thresholds considered safe for regular human consumption. The contamination therefore moves simultaneously through ecosystems and communities, affecting both fish populations and the people relying upon them as food. Hydroelectric dams continue reshaping Amazonian tributaries at increasing scale. River fragmentation interrupts migration pathways, alters flood timing, changes sediment distribution, and weakens the seasonal inundation cycles central to piranha reproduction. Nesting behavior, juvenile survival, and wet season dispersal all depend upon hydrological rhythms refined across millions of years of river evolution. Artificial regulation compresses and destabilizes those rhythms in ways the ecosystem has little evolutionary experience absorbing. Climate projections for the Amazon suggest further intensification of dry season conditions across substantial portions of the basin. Longer drought periods could concentrate fish into shrinking pools more frequently, increasing nutritional stress and elevating the same competitive feeding behavior historically associated with human conflict. The irony becomes difficult to ignore. Conditions producing the rare aggressive incidents that sustain the mythology are often themselves symptoms of ecological stress, acting upon the fish and the river simultaneously. In Western imagination, the piranha rarely appears as an animal needing protection. Its reputation has long implied invulnerability, as though sharp teeth alone place a species beyond ecological consequence. Yet within the real Amazon, piranhas function increasingly as indicators of river health, reflecting changes in flood cycles, contamination levels, habitat integrity, and food web stability. The fate of the fish remains inseparable from the fate of the basin itself, a living signal carried quietly through water systems under mounting pressure from nearly every direction. Far from film sets and tabloid headlines, most piranha research happens in humid laboratories beside holding tanks, in narrow aluminium boats moving through flooded forest, or knee-deep in warm river margins where visibility fades into brown water only centimeters below the surface. The scientists working in these environments rarely describe the animal in the language that popular culture inherited from cinema and sensational travel writing. Their papers read differently: patient, observational, sometimes quietly surprised by the complexity emerging from an organism long treated as scientifically uncomplicated. Among the most influential researchers was Ivan Sazima of the University of Campinas, whose field observations across Brazilian river systems repeatedly revealed feeding behaviors far broader than the narrow image of a specialized flesh eater. Through decades of work, he documented piranhas consuming fruit, scavenging opportunistically, removing scales from larger fish, and participating in ecological interactions far subtler than indiscriminate predation. The fish appearing in his notebooks was not a singular monster organized around violence, but an adaptable river animal responding flexibly to changing seasonal conditions, competition, and food availability. In many ways, the research slowly dismantled the mythology simply by replacing exaggeration with close attention. Taxonomic researcher William Fink of the University of Michigan encountered a different dimension of the same problem. Identifying and classifying piranha species required detailed anatomical comparison, geographic sampling, and patient systematic work. Yet public fascination continually pulled attention toward aggression studies instead. Interviews and discussions surrounding his work often drifted toward feeding frenzies rather than biodiversity or evolutionary history. The imbalance revealed something larger about the sociology of science itself. Funding agencies, publishers, journalists, and audiences all carried expectations shaped before the research even began. Some questions appeared inherently marketable, while others struggled for visibility despite being biologically more important. The assumptions surrounding piranha behavior extended even into modern laboratory studies. In the acoustic research conducted by Eric Parmentier and colleagues at the University of Liège during the early 2010s, researchers identified a structured vocal communication system composed of warning barks, pursuit drumming, and biting clicks. The existence of graded sound signals implied conflict management, behavioral escalation, and social signaling occurring before physical contact. Within the published discussion surrounding the work, the researchers noted that the complexity of the communication system had been genuinely unexpected. The mythology surrounding piranhas had quietly influenced scientific intuition itself, lowering assumptions about the behavioral sophistication researchers anticipated finding. Beyond species-specific studies, broader theories from behavioral ecology reshaped the understanding of piranha schools. The foundational work of Anne McGurran on collective fish behavior provided frameworks later applied to piranha movement dynamics, predator avoidance, geometry, and social coordination. Once analyzed through the same mathematical lens used for sardines, minnows, and other schooling fish, piranha collectives ceased appearing uniquely chaotic. Their formations followed recognizable principles of risk distribution, information transfer, and coordinated movement already documented across aquatic ecosystems worldwide. Field researchers working within Brazil's Pantanal wetlands often describe an even sharper contrast between expectation and reality. Foreign journalists arriving for expeditions sometimes anticipate rivers too dangerous to enter safely, only to encounter local fishermen standing calmly in shallow water while sorting nets by hand. Communities that have lived alongside piranhas for generations possess practical, seasonal knowledge about low water periods, spawning zones, discarded fish remains, and feeding hotspots, yet rarely speak about the fish with the exaggerated dread common outside South America. The disconnect can feel almost surreal, as though two entirely different animals exist simultaneously, one shaped by observation, the other by narrative repetition. Across decades of scientific literature, a consistent pattern quietly emerges. Each time researchers ask serious questions about piranha ecology, communication, cognition, evolution, or social behavior, the answers become more layered, more adaptive, and more biologically intricate than the mythology ever allowed room to imagine. Sometimes the mythology surrounding an animal spreads so quickly that it becomes detached from biology almost immediately, drifting instead into the mechanics of headlines, television segments, and shared fascination. The pacu became one of the clearest modern examples of this process, a fish transformed into an international menace, not through documented behavior or scientific evidence, but through a chain reaction of implication, repetition, and imagery powerful enough to outrun reality within days. The pacu itself belongs to the same broader Serrasalmid family as the piranha, sharing ancestry, body shape, and powerful jaws, while diverging almost completely in feeding ecology. In the flooded forests of South America, pacas spend much of their lives beneath fruiting trees, waiting for seeds, nuts, and fallen vegetation to strike the water surface above them. Their teeth evolved accordingly. Instead of triangular cutting blades, the pacu developed broad, flattened molars capable of crushing palm nuts and hard seeds that many other river animals cannot open. Seen outside the context of Amazonian ecology, however, those teeth create an unsettling visual impression. In photographs, especially when framed tightly against a dark background, the dentition appears strangely human. That visual coincidence became the center of a media storm during the early 2010s. Reports emerging from Papua New Guinea and parts of northern Denmark began circulating internationally, claiming that pacas were attacking male swimmers and specifically targeting human genitalia. Within hours, the story moved across television broadcasts, newspapers, and online news aggregators. Major outlets, including BBC, CNN, and The Guardian, amplified the narrative, often pairing alarming headlines with close photographs of the fish's teeth. The transformation from obscure tropical freshwater species to global horror story happened with extraordinary speed. The factual foundation beneath the panic was remarkably thin. A single pacu had been captured in a Danish waterway, almost certainly released from the aquarium trade into an environment far outside its native range. During interviews surrounding the unusual catch, a researcher casually remarked on the fish's dentition and its resemblance to human teeth. Somewhere between that observation and the headlines that followed, speculation hardened into narrative. Stories describing castration attacks spread widely despite the absence of documented medical cases, forensic evidence, or verified behavioral observations. No confirmed incident of the kind has ever been established in scientific literature. The biological logic behind the claim was equally fragile. Pacus are primarily herbivorous fish, whose feeding anatomy evolved for crushing resistant plant material. Their jaw mechanics, tooth shape, and natural diet align with seed predation, not selective attacks on large mammals. The famous comparison, suggesting that human anatomy might resemble floating nuts, was memorable enough to survive repeated retelling, even though behavioral ecology provided no support for the idea. The image proved stronger than the evidence. What unfolded around the Pacu revealed how little the mechanics of myth-making have changed since the era of Roosevelt's staged Piranha demonstration. A visually striking animal enters public awareness. A dramatic statement, whether speculative or exaggerated, attaches itself to that image. International media systems amplify the most emotionally charged interpretation because attention rewards spectacle more effectively than nuance. Once repeated often enough, the claim acquires the texture of common knowledge regardless of evidentiary weakness. The Pacu became a phantom predator built almost entirely from suggestion and repetition. The piranha became a symbol of unstoppable aquatic violence through much the same process generations earlier. In both cases, the underlying animal remained biologically real, ecologically important, and considerably more complex than the mythology surrounding it. Yet, complexity moves slowly through culture, while fear attached to a memorable image can circle the world before the river itself has even gone dark for evening. In the long shadow cast by the piranha myth, entire stories within the Amazon slipped quietly past international attention. While films, magazine covers, and sensational television documentaries returned again and again to razor teeth and imagined feeding frenzies, other animals, some genuinely dangerous, others ecologically irreplaceable, remained strangely absent from the global imagination. The mythology surrounding one fish consumed such a disproportionate share of cultural attention that it subtly rearranged the perceived hierarchy of the river itself. Beneath the dark surface of Amazonian tributaries lives an animal whose abilities exceed almost anything invented for the piranha. Electric eel, now understood to represent several closely related species rather than a single one, generates electrical discharges powerful enough to disrupt muscular control in large mammals. In the strongest recorded cases, the voltage approaches 860 volts, enough to knock horses from their footing or interfere with the electrical rhythm of the human heart. River communities have documented fatalities associated with these encounters for generations. The animal is not aggressive in the theatrical sense popular culture prefers, yet its biology represents one of the most extraordinary predatory adaptations on Earth. A living organism capable of weaponizing electricity in opaque freshwater darkness. Elsewhere within the basin drifts the far smaller yet deeply unsettling kangaroo, a slender, parasitic catfish scarcely larger than a finger. The creature feeds primarily by entering the gill chambers of larger fish and attaching internally while consuming blood. Rare medical reports and persistent regional accounts describe accidental entry into human body cavities, incidents disturbing precisely because they emerge from real anatomical behavior rather than cinematic exaggeration. Yet despite its verifiable biology, The kangaroo never acquired the same mythic global status as the piranha. Its story lacked the clean visual simplicity of flashing teeth and swirling water. Meanwhile, one of the Amazon's most intelligent predators nearly vanished under the weight of commercial hunting with comparatively little international notice. The giant otter, sleek and social, became heavily targeted throughout the 20th century for its dense fur. Across vast regions of South America, populations collapsed by roughly 80% as hunting pressure intensified. Entire river systems lost animals that had once functioned as dominant predators and important ecological regulators. While the piranha accumulated fear and fascination, the giant otter moved toward endangered status with only a fraction of the same media attention. Even the great sharks of the Atlantic occasionally disappear into the Amazon unnoticed. Bull shark possesses an extraordinary physiological tolerance for freshwater, allowing it to travel astonishing distances inland. Individuals have been documented thousands of kilometers from the ocean, moving through muddy river systems far removed from any coastline. The biological achievement is remarkable. A marine predator temporarily becoming a river animal deep within the continent. Yet the phenomenon remains comparatively obscure outside specialist circles. Then there is the arapaima, among the largest freshwater fish on Earth, breathing atmospheric air in slow gulps from the river surface and feeding communities throughout Amazonia for centuries. During the late 20th century, overfishing pressure pushed many populations into steep decline. Conservation programs eventually emerged in some regions, but the international response remained muted beside the endless recycling of piranha mythology. One animal became overexposed through fear, while another, far larger and ecologically foundational, struggled for visibility even while disappearing. The imbalance shaped more than entertainment. Public fascination influences research priorities, tourism economies, conservation campaigns, and political attention. By elevating the piranha into an exaggerated emblem of Amazonian danger, the mythology quietly redirected curiosity away from the basin's broader ecological realities. Some species requiring urgent protection remained obscure. Others, possessing genuinely extraordinary biology, stayed largely absent from popular understanding. The river itself became simplified, reduced to a single symbol, dramatic enough to survive repetition, while much of the deeper story flowed onward unnoticed beneath the surface. At night, from high above northern South America, the Amazon no longer resembles a river in the ordinary sense. It appears instead as a branching continental system, dark arteries spreading through forest larger than many nations, carrying sediment, nutrients, migrating fish, drifting seeds, and entire cycles of life across distances so immense they become difficult to visualize all at once. For much of the outside world, this landscape was reduced to a handful of exaggerated images: teeth in muddy water, boats drifting through danger, unseen predators beneath the surface. Yet once the mythology is peeled away layer by layer, the reality that remains is vastly stranger and more beautiful than the fiction ever managed to be. The Amazon basin contains roughly 3,000 documented freshwater fish species, more than inhabit the entire Atlantic Ocean. Even now, scientists continue describing new species every year, sometimes dozens within a single cycle of research expeditions and taxonomic revisions. Some emerge from remote tributaries, isolated by unusual chemistry or seasonal flooding patterns. Others existed in museum collections for decades before genetic analysis revealed that what appeared to be one species was actually several. The river remains biologically unfinished from a scientific perspective, still revealing itself piece by piece despite centuries of exploration. At the center of this complexity lies the flood pulse, the great annual transformation that rewrites the geography of the basin every wet season. Water rises through forests for months at a time, submerging roots, trunks, leaf litter, and entire plains beneath warm brown currents. Hundreds of thousands of square kilometers of forest temporarily become aquatic habitat. Fish drift between tree branches where monkeys moved only weeks earlier. Fruits fall directly into the water. Seeds travel enormous distances through digestive tracts and shifting currents. Nutrients circulate through submerged ecosystems with astonishing efficiency. The seasonal inundation is among the most productive ecological phenomena on Earth, a planetary scale exchange between forest and river repeated every year with quiet consistency. The water itself varies so dramatically across the basin that some tributaries function almost like separate worlds. In blackwater systems, tannins and humic acids released from decomposing vegetation stain the rivers the color of tea. Sunlight struggles to penetrate more than short distances below the surface. The chemistry becomes so specialized that organisms adapted to those conditions often cannot survive in clearer whitewater systems nearby. Species distributions follow invisible chemical boundaries carried through the basin by dissolved organic compounds accumulated across immense spans of time. The river is not one environment but many layered together, interacting constantly while remaining chemically distinct. Across all taxonomic groups, the Amazon basin contains an estimated tenth of the planet's known species. Insects, fungi, plants, amphibians, birds, reptiles, mammals, and fish overlap within an ecological network so dense that no scientific discipline can fully map it in isolation. Every submerged root system hosts microscopic communities. Every flooded tree canopy becomes temporary habitat. Predation, pollination, decomposition, migration, and reproduction unfold simultaneously across scales ranging from bacteria to river dolphins. The piranha occupies one position within this living architecture, important but far from central. That may be the most significant shift in perspective of all. The Amazon was never fundamentally a landscape of monsters waiting beneath opaque water. It is the most biodiverse river system on Earth, perhaps the most ecologically intricate freshwater environment the planet has ever produced. Reducing it to fear obscures the deeper reality of what is actually being threatened. Deforestation, mining contamination, dam construction, overfishing, and climate disruption now alter the basin faster than many species can adapt. Forests that once flooded predictably experience changing seasonal rhythms. River chemistry shifts, migration routes fragment, entire ecological relationships strain under accelerating pressure. When the Amazon is framed primarily as hostile wilderness rather than extraordinary biological infrastructure, its destruction becomes easier for distant audiences to emotionally dismiss. The mythology did not merely misrepresent a fish, it narrowed the world's imagination about what the river truly is, and about what is being lost as the water slowly changes. Long before cinema screens, newspaper headlines, or viral internet stories, human beings were already telling cautionary stories about animals with sharp teeth, forward-facing eyes, sudden movement, or unusual behavior. Around ancient fires, in villages at forest edges, beside rivers whose depths could not be seen clearly, survival often depended on rapidly identifying danger. Evolution rewarded minds that reacted quickly to potential threats, even at the cost of occasional exaggeration. In that sense, the roots of the piranha myth reach far deeper than one expedition or one film franchise. They emerge from ancient psychological architecture, meeting modern systems of amplification. The process follows a pattern so consistent that it becomes difficult not to notice one seen clearly. First comes a real biological trait, something genuine and observable. A piranha possesses sharp, interlocking teeth. A shark can remove enormous tissue with a single bite. Wolves hunt cooperatively. Bats emerge at dusk in large moving groups. None of these facts are fictional. Yet, isolated from ecology, behavior, and environmental context, the trait begins to detach from the animal itself. Teeth become savagery. Predation becomes malice. Adaptation becomes personality. Then comes the catalytic moment, usually dramatic, exceptional, or artificially staged. Roosevelt's orchestrated feeding frenzy fixed the piranha in the public imagination. Early 20th century shark attack. Reporting transformed statistically rare incidents into symbols of oceanic terror. Livestock killings during periods of prey scarcity shaped centuries of wolf mythology across Europe and North America. Singular moments, stripped of surrounding conditions, become presented as ordinary behavior. The exceptional quietly becomes representative. Modern media accelerates the process with extraordinary efficiency. Dramatic stories spread rapidly because they produce strong emotional responses and require little explanation. Corrections move more slowly. Nuance travels poorly through headlines. A photograph of exposed teeth circulates farther than a careful ecological analysis. Entertainment industries then reinforce the imagery because fear sells reliably across cultures and generations. Films, tourism campaigns, merchandise, documentaries, aquarium sales, and sensational news coverage all begin feeding the same symbolic ecosystem. The animal becomes commercially valuable precisely because it has ceased to resemble itself. At a certain point, the mythology stabilizes into cultural memory. Children inherit it before encountering the real animal. Adults repeat it casually, often without remembering where they first learned it. Attempts at correction can even feel emotionally disappointing, as though scientific accuracy has removed something entertaining from the world. The fictional version becomes psychologically satisfying in ways the real organism was never designed to compete with. Behavioral psychology offers insight into why these myths endure so effectively. Human beings display a measurable preparedness to rapidly acquire fear responses towards certain visual patterns and movement cues associated with ancestral threats. Eyes fixed forward, exposed teeth, rapid motion, erratic silhouettes, and sudden appearances capture attention unusually efficiently. Media systems exploit this tendency constantly because emotionally charged animal imagery produces reliable engagement. The nervous system reacts before the analytical mind has fully processed context. The consequences extend far beyond misunderstanding. Wolves were exterminated across enormous portions of their historic range because mythology framed them as existential threats rather than ecological regulators. Shark populations now collapse globally under pressure from overfishing and fear-driven policy. Bats, despite their immense ecological importance as pollinators and insect controllers, are persecuted in many regions through exaggerated disease narratives disconnected from actual epidemiological risk. Entire species can spend centuries carrying reputations constructed more by folklore and commerce than by observation. The piranha belongs within this larger pattern. A real fish, biologically fascinating and ecologically important, was gradually replaced in public consciousness by a symbolic creature assembled from selective truths, staged events, cinematic imagery, and repetition. Even overwhelming contradictory evidence struggles to fully dislodge the invented version once it becomes culturally embedded. Perhaps that is the deeper lesson resting beneath the river itself. Human beings do not merely observe animals. We continuously rewrite them into stories that reflect our fears, desires, economies, and imaginations. Sometimes the fictional animal becomes so large in culture that the real one nearly disappears behind it, still moving through dark water, unchanged by the mythology built around its name. By the time the myth falls silent, the river itself begins to sound different. Not safer, not simpler, but clearer. The exaggerated image that once swallowed every other detail gradually loosens its grip, and smaller truths begin surfacing from beneath it, like shapes emerging through tannin-dark water at dawn. The frenzy fades first, then the monster, then the idea that this animal existed outside the ecological fabric surrounding it. What remains after all that removal is not emptiness, it is specificity. A fish roughly the size of a human hand, laterally compressed for movement through submerged roots and flooded forest, carrying a jaw architecture refined over millions of years for precision rather than chaos. Its teeth still interlock with extraordinary efficiency. Its bite still matters, yet the meaning of those traits changes completely once they are placed back into the environment that shaped them. Teeth become tools again. Aggression becomes conditional behavior instead of personality. The river stops looking like a stage set for horror and begins looking like what it always was, an impossibly dense web of negotiations among living things. The red-bellied piranha survives in water so dark that vision alone becomes unreliable. In those conditions, it listens constantly through pressure-sensitive receptors running the length of its body, feeling movement patterns in the surrounding current with astonishing sensitivity. It samples chemistry continuously, detecting traces of blood, stress compounds, decaying tissue, and reproductive signals dissolved invisibly through the water column. In territorial disputes, it produces low acoustic warnings through rapid contractions of the swim bladder, creating structured sounds that often prevent escalation before physical contact occurs. Long before cinema transformed it into a symbol of mindless violence, the animal itself had already evolved systems for caution, communication, and restraint. Its entire life shifts rhythmically with the flood pulse of the Amazon basin. During rising water, submerged forest expands outward for hundreds of kilometers, opening temporary worlds among drowned trunks and fruiting trees. Diet broadens, aggression decreases. Nesting begins among roots and aquatic vegetation. Males remain near adhesive eggs, fanning oxygen-rich water across developing embryos and driving away intruders many times their size. Months later, the water retreats again. Channels narrow, competition intensifies, and the behavioral atmosphere changes with the river itself. Few vertebrates on Earth live within an environment that physically rewrites their world twice every year on such a scale. The animal also spends much of its existence attempting not to be eaten. River dolphins isolate individuals from schools with echolocation precise enough to track movement through murky water. Giant otters seize them along the edges of feeding groups. Black caimans consume them in large numbers. Wading birds spear juveniles from shallow margins. Humans catch them routinely with baited hooks, nets, and traps. The schooling behavior that Western mythology interpreted as predatory organization now appears in a different light, a defensive geometry built by an animal surrounded constantly by danger. For more than a century, the piranha carried almost no public identity beyond the story imposed upon it after Roosevelt's expedition. a staged feeding event hardened into global mythology, reinforced by film, tourism, sensational journalism, and repetition across generations. The real fish remained underneath the narrative the entire time, unchanged by its own reputation. And the real animal turns out to be considerably more remarkable than the fictional one, not because it is secretly harmless, but because it is specific, adaptive, sensory-rich, socially responsive, and ecologically entangled within one of the most biologically complex systems on Earth. Once the mythology dissolves, what remains is not disappointment. It is a clearer encounter with evolution itself, shaped by dark water, seasonal flood, competition, fear, communication, and survival across millions of years of changing rivers. Night settles across the basin without spectacle. No soundtrack rises from the water. No frenzy erupts beneath the surface. The river simply continues, carrying dissolved forest and mountain sediment across a continent exactly as it has for millions of years. Tannins darken the current into something almost opaque, a moving body of chemistry and memory flowing eastward toward the Atlantic. Beneath that surface, pressure waves spread invisibly through the black water, crossing roots, submerged trunks, drifting leaves, scales, fins, and mudbanks in continuous, silent exchange. Somewhere within that darkness, a school of red-bellied piranhas holds formation against the current. They are not performing for mythology. They are not behaving like symbols. Each fish maintains position through constant sensory adjustment, reading water displacement through the lateral line with exquisite precision, staying near enough to neighboring bodies that the mathematics of collective survival continues working in its favor. The outer edge remains more dangerous than the center. The school shifts subtly around that reality every second of the night. For approximately 25 million years, animals, very much like these, have been navigating rivers shaped by flood, drought, sediment, movement, tectonic uplift, and ecological competition. Entire climates changed around them. Ice ages altered rainfall patterns across continents they would never see. River channels migrated, forests expanded and contracted, predators evolved and disappeared. Through all of it, the piranha lineage persisted by remaining deeply fitted to the conditions surrounding it, rather than dominating them. Farther upstream, beyond the range of human vision in the dark water, a boto moves slowly through submerged forest edge. Sound pulses outward from its forehead into the river, mapping fish, roots, branches, and suspended debris through echolocation, so refined it can isolate movement inside total darkness. The dolphin hunts in a sensory world entirely different from human perception, constructing the river from echoes instead of light. Nearby, juvenile fish shelter among drowned vegetation. Insects settle across the water surface. Caustic black water presses quietly against exposed roots, waiting for the flood season still months away. When those rains return, the Varzea forest will disappear beneath rising water again. Trunks will stand submerged in warm floodwater, carrying nutrients across immense distances. Fruit will fall directly into the river from inundated branches. Piranhas will move outward from channels into temporary forests, feeding not only on fish but on seeds, insects, and drifting organic matter among submerged trees. The landscape will transform completely, then slowly contract once more when dry season returns. The entire basin breathes in this rhythm, expanding and narrowing on a scale large enough to reshape behavior across thousands of species simultaneously. The Amazon itself remains almost impossible to fully comprehend. It contains more biological diversity than any river system on Earth, more evolutionary experiments unfolding simultaneously than science has yet cataloged. Even now, species move through these waters unnamed by formal taxonomy, carrying behaviors, sensory systems, and ecological relationships still unknown outside the basin itself. The old mythology reduced this vast living system to a theater of monsters. Reality turned out to be stranger, richer, and infinitely more interconnected. And the genuine danger surrounding the river was never concentrated in the fish. It exists in chainsaws, opening the forest canopy kilometer by kilometer. It exists in mercury from mining operations, dissolving into waterways and accumulating through food webs. It exists in dams, interrupting flood cycles that shaped Amazonian life for geological ages. It exists in the accelerating simplification of an ecosystem whose complexity took millions of years to assemble. The piranha survived predators, climatic upheaval, continental reorganization, and relentless ecological competition across immense spans of time. Whether it survives the coming century depends not on its teeth, its aggression, or its mythology, but on decisions made far beyond the black water where it still drifts tonight, holding formation in the current beneath a dark and living river.